All right, so what I'm going to do is I will share my screen and let me share that. You should see uh, a file explorer and what I call my colored Pringles. I know they're not really Pringles, but they look like it. And but then here we've also got um, oh, let me see now. Now are you able to see my screen now?
Yep.
Okay, good. So, and you can maximize that if you'd like to as well. So, if you haven't already. So we're going to be sort of working through a couple of examples in the books, but I wanted to take a few minutes and show you the structure of these manuals. Were you able to download your data sets and your manuals? You got all those okay?
Yes.
Okay. All right, good. So what we have are basically two manuals. We have this one called the Civil Design Module because that really covers the basics of design in terms of the generalized grading and 3D modeling, that sort of stuff. But then we also have included there this tutorial. Now, this is a couple of versions back. You can see both of these are actually pretty old now. The techniques are all still the same. And this one, which is a huge file, I think it's like 829 pages. But here's what this one is, and let me point out to you to keep from worrying about these. All of these different commands that the very first thing starts out on chapter one, a little bit of standard stuff, and then it starts talking about the menu commands, and it goes through every command. File, then edit, then well, it's still under edit, and then view, then draw. So these are all commands, but they are taken from that product I was telling you about, that standalone product, the R9, R10, R11. I think they're up to R12 now, release 12, that standalone product called Takeoff. So they're not going to exactly correspond with the same locations. They're going to be in there. However, you've got all of that stuff available as well in your civil manual that does correspond to your system. But here's the way I would use this particular manual here. It's fairly decent once you get past all of these commands that you're going to see and just step through all of the different commands, and then or after you get past all the menus, and see now we're still down to like the drill hole menu, the inquiry menu, and then finally settings menu, display menu, BIM, help. And now you get to the tutorials menu, and there's where that's where the meat is. Okay. So they have you several different little tutorials that work with the sample files that come with Carlson when you install it. So here's this CAD file takeoff from start to finish, and we're going to run through part of this, and it shows you, it starts with this drawing that is actually that's also a real site out in somewhere in California, I think. Uh, I thought maybe they had a picture of it on the ground. I'm not seeing it in the little thumbnails here, but anyway, you can refer back to that, and that's a decent little tutorial sort of ish on building surfaces. But the The other nice one is like this road design, drill holes, and then trenching. For instance, so this would be if you were to run your trench module. All right, it's just a little, step by step on how, with the sample file, how to lay out a pipe alignment. And then you take the profile data and you set up the cross-section shape of the trench and then apply, that what you looked at here was, for instance, that's the color coding of the depths. Sorry, this thing keeps jumping on
So
me.
should I be seeing something on your screen?
Yeah.
All I see is the zoom. I'm not.
Oh, gosh. Yeah. Let me see. All right, I'll stop sharing. So now you should see, there should be two windows. Like you've got the Zoom window that's got your and my name in it. You can minimize that. But there should be another window, and it could be a small one. I don't know if you've got multiple monitors. It might be on the other monitor. Do you see that?
So
Like you should see a window that's got it's got a window with your name in it. It's got a window with my name and a little still picture. You should see that. That's the meeting window. You see that one? It's
yeah,
got
it says
it got
the meeting is being recorded, and it's a picture of you.
yeah, and does it have buttons down at the bottom, like with a microphone and a camera?
Yeah,
Okay, so that's the main view window. Now look for another window. It should be open on the screen somewhere. It could
on
be,
that screen
I don't know. It
in
depends on
in
how,
the Zoom workplace screen.
I'm not sure if take that window that you're seeing and move it and see if there's something behind it. Uh, it- but there should
No.
be, you should actually have a second window. All right, so if I do this, if I come in here, if I share, okay, so now you should see your,
Now I see. Oh, step 8, draw a trench.
yeah, okay,
Your profile.
now you're seeing it. Okay. So that's what you should see. And that's where we'll be doing. And again, that window, you can maximize it if you want, however you want to best use it. Okay. And it's the other window that was basically has just the meeting participants in it. That's what you're seeing on that other one now, which should be smaller than it used to be now.
Yeah.
Okay. All right. So we'll come back up to this. We've got two manuals here. We've got the civil design module manual, which is what we'll be using for some of our sample files. And it's again the same one that we use to teach the civil class with, but it has a lot of the grading commands and the road building and that sort of stuff. But the other manual that is included here, this one that's the Carlson takeoff
Mhm.
user's manual, and this is the full user's manual for that product. And again, it has all of these commands and these different menus that you're seeing here in the table of contents. And they talk about those particular commands out of that product, which we're not going to line up exactly with where those commands are located in your version, because this
Right.
is that standalone version. But if you go to the last page there, this is actually page 17 of the document. Um, but it's the end of the table of contents, and you see this tutorials menu. So there's basically a little thing in the tutorials that you can get to from the help system. But if you just go to each, hold on a second, let me get back to where I came from. I was here. So if I look at this first tutorial, this CAD file takeoff from start to finish. So if I click that, that's going to show me the step by step by step of that little tutorial, that process of how to take this site and grade this site. Um, and it works with these little files that are part of your installation, drawing 1, drawing 2, and or demo 1, demo 2, and demo 3 that are included when you installed your product, and they live in this folder called C Carlson projects. Okay. If they should happen to not be there any further, then I think we've also included them in the data sets, maybe not. Yeah, they're in the data sets folder. If you look at where this is my 3D machine control class, and I had this data sets in this getting started folder, they've been re-included there, these demo 1, 2, and 3. So if you don't have them in your Carlson projects folder, you can get them out of this example here as well. Okay.
All right.
So that's a good little tutorial. There's a couple of things about it, and we're going to step through parts of it because I want to show you where this tutorial is a little bit off, and they don't really address a couple of things that we need to be able to do to fix some problems that we're going to be able to see once we get that done. But the process is good of how you run through this from the takeoff approach. Okay. But then if you go back and look at the next tutorial out of that list, which I can get to here, there's these other ones like road design with volumes, and that uses the actual road net, design it. You sit here and design your curbs and your cross-sectional shapes. Here's the road bed and the subgrades underneath it and the curbing. Let me see here, get this back up to there. And then it, just shows you, and then how to compute the volumes from those kind of construction efforts. Drill holes and strata. This is if you've got drill hole data where you've got drill holes that show you at certain depths of, in the drill hole, you encounter certain different materials, clay or shale or limestone or whatever it happens to be. And you can put that data in, and it actually builds a subterranean model of those strata layers, and it will then use those to sort of subdivide your volumes when you run your reports. It knows once it gets down into those different materials, it starts to consolidate the what used to just be, let's say, you got 1,500 cubic yards of material that you're excavating, but if you have this extra data, then it will say, well, 350 cubic yards of that were clay, 200 cubic yards of that was, it's a river or, a gravel silt mix, and maybe you got topsoil amounts. And so it sort of helps to refine that process. Okay. But, we a lot of times don't have that data. So, but it's there if you ever need it. Now, the other one that is good is this trenching. I'm sorry, my screen is just bouncing around. Here we go. So this trench, another takeoff tutorial, this trench quantities, this shows you how, they've laid out a pipeline here, and then they've established the, the materials and the width of the pipe or the diameter of the pipe, the wall thicknesses, that sort of stuff. And then you define the shape of the trench and how much is got of varying different materials. And then you can define, you want to see your drawing, and it will color code it based on, if you see this legend here, things that go from 0 to and I don't think it legend's exactly right. 0 to 15 feet are the red color. The yellow color are 15 to 20 feet deep, then 20 to 25 in the green, and then anything over that would be this light blue. So, just some of the things that particular module will do. So it's a nice little exercise to step through. It's real simple to go through it. And so I wouldn't, worry too much or spend too much effort in this manual going through all of that stuff up front, other than just go right to that last page of the table of contents and take a look at these tutorials. Okay. So that's it's a decent little thing. Now I'm going to go ahead and just close that down, and we'll talk about what we have going on in hours. So in the approach that I like to take, Philip, and when I do my teaching, is to give you the tools to sort of think your way through a process, more so than step one, step two, step three. Do this step one, do this, and this, and not understanding what's going on there. And that's really more like those tutorials that we were just talking about show you how to do. But like I said, they sort of gloss over some problems with that data. So it's a real good approach to find out how, once we understand that process, then how do we analyze it and figure out where some data might have some problems and how do we fix that? Okay. So that being said, I'm going to point out a couple things in these manuals. Now, these are ones that I wrote, not from Carlson. And so you're going to see in here, there's some different, little exercises are shown here in this red face, and they're all hyperlinked here. And, it talks about points, point groups, and this little putting things together, that's with a little surface model and generating some volumes. That's just very straight, things you can do in the survey module. You don't need yours, the module that you have that is a little more specialized, although you can do the same types of work. Then we get into, once we're into the civil module itself, there's a roadway design and some grading tools designed. For instance, if we've let's see, here's a building, for instance, that we're going to build, and it's going to have a parking lot, and it's going to tie into this road over here on the right. So we're going to have an approach driveway. And so this will step you through that. This is a building pad that little L-shaped building is going to sit on. And then here's the parking lot. And then we would design that such that, say, the parking lot is so many feet away from the edge of the building pad at a certain slope down from it. And then the building pad is going to be level all the way out, but the parking lot's going to slope downhill. And so we're going to, this would step you through all of these potential problems where you've got these little overlapped areas, and, where this fill from the building spills over into the parking lot. So, how do you fix those kind of issues? And they may not be anything worth taking the time to fix if you're just doing this to get some rough quantities. But if you're doing this because you want to put it on a dozer and go out there and build it with your GPS driving the dozers, then you're going to need to fix some of those issues. And here's a case where the building pad was actually going to be cut in this area. The parking lot from the original ground. The parking lot was also cut from that original area. And you put those two side by side, and those two little cut banks, go up and make a little hump, a little V-shaped hump, which, we need to know from there. We don't need to construct that hump. We need to just go from this, from this point right here on the edge of the pad down to this point down here on the edge of the parking lot. that can just be a straight line instead of going up and then back down and up and back down. You can just tie those things together. So, you know, some little techniques that you're going to see how to control this process. So that will be sort of what we do. So we're going to be jumping in and out of some of that kind of work. So we won't be, you know, we're not going to be going through this book, page 6, turn to page 7, turn to page 8. We're not going to go approach it that way. But that's going to serve as our guide. And in particularly, it's going to be a good leave behind for you all to work with. You know, you got some good reference material to make it happen. And you can always at any time too, after the class, keep track of that email where I gave you the download link to get the class materials. And you can always go back there and get them again. They're freely available there. So now in the book also, you can see there's a little bit about me. It's actually this number 30 should be 40 now. It's over 40. So getting so close to being able to retire. But anyway, what that's meant to do is simply reassure you, I've done this for many years. I've seen this stuff and know how to step through all the little traps that a lot of people fall into when they're working on it. But here's the key takeaway from all of that is this in my email address down here that, you know, keep track of that. And anytime you've got a question on this stuff, how to do this, how to do that, or even if it's not something that we've talked about in class, by virtue of the fact that you are an MSoft customer, you now have access to us as a resource. So you can use us for tech support on the product, or even, you know, hey, I was wondering if this approach would work. What do you think? Or what would be another way I could do this kind of thing? You know, just keep that handy and stay in communication. So we, you know, like I say, I tell some other people, I've got people that still send me some questions and stuff. There's a government agency up in Canada, up in Windsor, that they sent, oh, I don't know, 7 or 8 people down to Pittsburgh to be trained once. Went back home the following year. They had me come up there to train them. So we got another 10 or 15 of their people trained. And now when they get, you know, somebody might be moved into a new job, they might have a new hire. And so they'll just call and have a little, you know, how do we get them started with the best approach? Or, hey, we've been doing our road profiles like this. Is this correct? How would I do that the right way? And so, you know, we still help them out. That's always what you have available. Okay. So with that, let's take a look at a couple of things here. Right in here, you're going to see sometimes in the book, you'll see these little pictures off to the left or right. Let's see if I can find one. Yeah, here's for instance, when you see that, say, hey, here's a note, okay, or here's a light bulb. Hey, here's a good idea. Here's just something to take note of. Okay, so little things like that. The other thing, let's see, we talked about those. Directory structure. You've used Carlson enough. I'm not going to spend any much time on going over you know, the settings and all that kind of stuff. But we'll go over the ones we need to know about. But and they're going to be the ones in here under the takeoff, this takeoff site-net settings, and a couple of other ones that we'll pay some attention to. Points. And then there's little exercises. Now, you know, you're probably, do you use points, you know, like creating points from a survey, or you make points from Let's say you take a building, you get your building corners and generate points to go stake out the building.
Mostly we just use line work now.
Okay,
They used to do all points, but
okay. Yeah, I was going to say it's not required that you use points at all. In fact, I've done quite a few really big projects. Um, you know, many thousands of acres, like for a nuclear power plant expansion, and then one for a school district, storm system retrofit, all of this kind of stuff, and didn't use the first point on it. So you don't have to do that, but it's something that surveyors just know points in their bones, for instance, and so they do everything with
right.
points, and it's not a bad approach. Um, so anyway, that's what these little exercises in this upfront part are going to be talking about. And now, how familiar are you with, for instance, modeling surfaces? Like when you go to build a surface, what's your approach to that? I mean,
So like a road surface,
uh-huh.
I would I'd go in and input the profile,
Mm-hmm.
and then
You got the
um,
center line and it has a profile.
right,
All right. And then,
and then I'll draw it in offset 3D.
okay.
And
So,
there's another I use that, for like when cross slope is changing, I'll
mm-hmm.
use the offset 3D polyline by grade table a
Yeah.
lot.
Okay. All right. So that's going to correspond with, and here's the reason I ask you that. Let's see, when we get to, this is in the civil manual, and which is really the portion of it that we're in is really when this section runs out before we start the actual civil exercises in the module, that's actually the end of our fundamentals class. But what it is like here's a bunch of points, say from a survey. Um, if you can see there on the right hand page,
Yeah.
and it's a stockpile. Okay, so we're going to use that. We get the perimeter of the stockpile, and then we generate the from those points. We create a terrain model of this stockpile, and it can then draw contours and all that. We can figure out some volumes of it as well. Um, but then the next thing that we talk about, see, there's doing computing the volume, but we're going to design a little access road to get into that because basically we're going to design a borrow pit out of that stockpile. Okay, so we did that and approached, let's see. So we got the volumes, then we know we need a certain volume of material, so we designed that as a little borrow pit there. But then, then merge that into that original. But then we need to put a little road that comes up and so your trucks can drive up in there and get to that borrow pit. So this is that same approach that you were talking about doing right there. Is see that green line? That's my center line that I'm going to use. And it comes up with, a couple of horizontal curves and then goes through a curve and comes into that borrow pit. Over here is what the profile along the existing ground looks like. And so then I'm going to need to take that and design a road profile. Now, this should all be the same approach that you're doing, right? And so you've got now, and you may not, you're not going to necessarily just freeform this. You're going to put it in based on some road plans that you've got probably.
Right.
Um, so, which is perfectly fine. Uh, And then we did that same thing. I thought I had a picture of the thing. All right. So what we did as this process is that we drew that the resulting 3D polyline of that roadway center line. And then we offset the edges, you know, I don't know, 20 feet each side or two, whatever we did for this example. And we used that 3D offset. We just offset them a constant width at a -2% grade. And then we took those outside edges that were then offset and we had them find the existing ground. We used design pad template to do that. Is that your approach? Or do you just use 3D offset and have it go to a surface?
Um, Generally, I don't deal with existing contours,
Okay.
so we did
So
do we did a dredging job that where we laid a pipe across the river, and
yeah.
I built the surface to tie into that, but
But like how do you when you build your road that you were talking about your approach, you did your offsets over here, then how do you tie those edges back to the existing ground? Because there's material there. You know,
right.
there's fill or cut in those side banks, and sometimes a significant amount. So what's your approach to doing that one? Do you and there's two ways of doing that is you can take that edge and when I say that edge, what I mean is you're taking this outside edge of the pavement, let's call it, even though this is just a gravel dirt road. And then we're saying go out and seek the surface in this direction. And if you have to go down to do it, you're in fill. If you have to go up to do it, you're in cut. Same thing on this other edge over here. And then there's two ways to do that. One is that you can take that line and just like you did the center line to make the edge of the pavement, you did a 3D offset. Well, you can take this edge line and you can do a 3D offset and have the target be that existing ground surface that you made, that somebody made, right? And then that will tell you where that daylight line is, and that'll be the footprint of that. And then all of that stuff in between is material that you have to account for. The other approach is a command in the software called Design Pad Template. And it's on the surface menu and it lets you take that and it essentially does the same thing, but it draws some additional things for you. If you remember the picture that we looked at a minute ago where the building was next to the parking lot and it had all those little red and blue lines that indicated those side slopes, that's what that command does, is it draws in all of those little uh, sideline connection, okay? So now that is this approach here. We did a center line, we drew it in 3D, we offset the edges, and then we offset the edges, okay? And that gave us enough to do something like this where, you know, we tied the road surface into the existing ground. We tied the borrow pit into the existing ground. So that now is what our finished ground is going to look like. Okay. And that's a perfectly valid approach. However, we've got some additional tools that you can take advantage of in the software that you have. And here's an example of a roadway design that you not only, you know, what we talked about just a minute ago was you built the center line over here and then you offset to this side. But this is going to let you also account for the thicknesses of the pavement and the stone and the under, you know, the subgrades, the curbing, and then all of these other little incidental things like maybe there's a 4 foot wide buffer area over here that pitches the water back to the road, and then it sits on a 3-to-1 fill or cut. So that's a different approach to designing the road is you're going to design the cross section of the road, and then you're going to push that cross section down that entire center line, and it's going to change vertically by way of the profile. So it knows the elevation at every point along that center line. So it's going to take that cross section and push it down the center line and ride that profile up and down. And then it stitches all of those little slices together into a continuous set of volumes. And then that's going to give you the amounts of material that you're going to need to come up with to build those roads and such. So that's a sort of a slightly different approach to building a road, using some of these a little more advanced tools that you have access to. Now, the quote Carlson takeoff end quote approach to doing this would be a little bit different. In what you look at here, this is the Carlson civil design approach, but the takeoff approach is you're basically going to draw the outlines or tell it where the outlines of those roadway where the roadway envelope is. And then you say, okay, so in between those edges, I've got, say 8 inches of, number 57 stone. I've got 6 inches of 2A stone. I've got 1.5 inches of binder course, and I've got a top course of a 1 inch of a wearing course of asphalt. And then for the entire length, I've got this type of curb. So basically, you're going to give it the plan view. You're looking down on it in plan view, and you're looking at it as edges, and then you're telling the software everywhere within that edge, I'm going to have this particular thickness of materials. So whereas civil takes it as a horizontal slice, a cross section, and it pushes it horizontally, the takeoff approach looks at it vertically, looks at it in plan view, and accumulates material in vertical lifts instead of in horizontal spreads. Does that make a little bit of sense?
Yeah.
Okay, so we're going to take a look at both ways. Now, my particular preference is to do things with more of the civil tools because, I'm a civil engineer. I'm not, I'm not just, I don't just necessarily limit myself to trying to just computing volumes of earthwork, because I'm doing more than that kind of stuff. I'm doing some higher accuracy grading, and I need some of those tools. So even with that, even with the takeoff product, you can still do all of those types of things. You can model your surfaces very precisely. And then in the takeoff workflow, where you normally will tell it a list of layers that represent existing conditions and another list of layers that represent design conditions. And so it pulls things out of the drawing based on what layers they're on. The other approach to that is that you can say, instead of doing that, you can assign a file name of a surface that you've already built. So if you've built a more precise surface and have it available, you can say, all right, forget about the layer list. I've already built the surface for you. Go and use this file. And so it's just a different approach. So takeoff allows you to get that done uh, both approaches. Okay. So with all of that said, let's take a look at now the process. So I'm going to go ahead and start up my Carlson 2025. And you say you use IntelliCAD, right?
Yeah.
Okay, so I'll use the IntelliCAD version here. I've got them.
All the way to the right, the takeoff suite.
Yeah. Yeah, that's another wonderful thing about this Carlson software is that it's built on top of IntelliCAD. So if you don't have AutoCAD, it's running on top of it. I actually have come to prefer IntelliCAD over AutoCAD, just because to me, does a better job. Okay. So I'm gonna go ahead now and let's go ahead and oh, let's go ahead and open files. Okay. So if I want to open the file, I'm going to navigate to my class folder, to the data sets that you downloaded. So I'm going to open up my Carlson projects. Here's my 3D machine control class. Here's my data sets folder, and I want to look inside this folder called Getting Started. Okay. And I want to look at this demo one. So when that comes up, you should see this. Now, you say you just upgraded yours. Did you get this little pop-up?
Yeah, it
Okay.
usually only pops up when I try to import DGNs.
Well, yeah, that's because it's DGN files are actually drawn with a declared unit of US survey feet mostly. And, when we're talking about the types of files that we have. And so it's just basically telling you that, hey, I've noticed it might be a mismatch, so it's not a problem. Now, what this one is telling me here is that it does not have any drawing units configured in this drawing, and the current units that we say that the file has, which are US survey feet, has been applied. And if you want to change that, run drawing setup. Okay. It's just a little warning message so you can tie it all together. So what we're going to do, I'm going to go ahead and run drawing setup. And this is something you could have done independently of everything else. It's on the settings menu, the drawing setup. So it is in inch equals feet, and it is in US survey feet. That's what I needed to have. Okay. And let's see, this is going to be on a 50 scale. I think I'm going to change that scale to be a 20 scale. That's probably more like what that would be based on the size of that drawing. Not sure. And then I'm going to look down here. Everything looks good. Now I'm on a grid system, which is the northing and easting system that is regular space, 90 degrees kind of stuff. A local system is just like an assumed 5,000, 5,000. A grid system is a named grid that's based on a projection, okay? And so I've got universal transverse Mercator, I've got state plane 27, or I've got this predefined or user defined, which is what we're going to really do most often. Then I'm going to choose this define projection, and it's going to bring up a list of things for me to choose from. Now, notice my list only has one system in it, the Pennsylvania, it's NAD 83, North American Datum 1983, the 2011 adjustment, Pennsylvania South Zone. Okay. So all this is just a pre-selected list of things I have available, but I can come down here and add other ones that are also predefined, and I can get from different places in the world. I want to use USA, of course, for here. And if I search for Pennsylvania, these are all the Pennsylvania ones I've got available. However, I know that this file is in California, and I'm not sure which one it is, but we'll find out something here. I'm going to take all of these. Can I do, it's not gonna let me do more than one at a time. All right, I think I'm just gonna grab all of these first 1, 2, 3, 4, 5, 6, and I have to add them one at a time, unfortunately. 2, 3. And I'll add 4. Five. And then I'm going to add one more here. The last one here, 6. And I'm going to say, okay. Now, all I've done with this is I've added this to my available codes. And if I choose Pennsylvania, for instance, and say, okay, it comes up here. You see right there to the side, it says I'm using the Pennsylvania South. But I know that it's in, I think it's zone 2, and we're going to find out here in a minute. And I'll show you what that's useful for. So it is, well, let's set it to zone 2. And we'll say, okay. Now we've defined our file to be using California state plane coordinates, US survey feet in zone 2. And California is divided into 5 separate zones. So whether that's the right one or not, I don't know yet, but we're going to find that out by, let's go to the settings menu and what do we want to do? The Carlson menus. I think we want CADNet. And once that's loaded, I'm going to go to the raster menu. Let's see if it's available here. See it under raster there. All right, let me go back to settings. Carlson menus. All right, now you say you've got geotech, construction, CADNet, and which else? Oh, trench, right?
Yeah.
Okay, so you don't have the GIS menu. Let me see if we've got. Bear with me one quick second here. If I'm what I want to do is place a Google Earth image. Let me see where that's only in the GIS. It's under images, Google image. Yeah, it's only under the GIS module. All right, well, this is that little example I was going to show you about to help with CADNet. So if I say this, I'm going to call, I need to give it a file name. This is a new file that doesn't exist yet. And I'm going to call this demo 1-1, just to give it a unique name. Where I want to pick it from the screen or from a map, I'll say from the screen. And I'm going to come down here and just give it some coverage. And it's going to go out there and it's going to find everything available from Google. We're using aerial imagery, high resolution, and say, okay, now if it comes into like a cow field, I know I'm in the wrong zone. If I see the actual parking lot and the edge, all right, so that's the wrong zone. All right, so I'm going to take that and delete it. And I'm going to go back and switch zones. So I'm going to go back to my drawing setup and my projection. I think maybe it's zone 5. if I knew that, now I'll go back to image and say, place Google Earth. And we're going to call this one demo 1-2 by screen. Again, wrong one. All right. Try this. Oops. Got to do this first. Well, 1, 2, and 4. I don't think. Let's go back and just start them at 1. And we'll do. Nope. So we've tried 1, 2, and 5. So we get 3, 4, and 6. It'll probably be the 6th one. Try. Wow. Good heavenly days. Shoot. I knew it. All right. So must be 6. And if it's not that, then I've got something wrong with my memory. There it is. All right. So now you can see. In fact, I'm going to turn this down a little bit in intensity. So you can see the CAD file and it overlays the image. Okay, now let me get. And that would be basically what they're trying to do here in this sample is to build this a parking lot and buildings. Now you can see where they've already actually built this. And you see how these edges of these concrete don't line up with the outline, say this
Yeah.
yellow outline, and the curb islands don't line up. So here's the nice thing about that, because this is just a Google Earth image and it's notoriously inaccurate. Um, so what you have in those tools then under CADNet is under the, oh, let's see, that's field, sorry. CADNet, I turn field back off, is under the raster. You've got this command called rubber sheet. Okay, and so rubber sheet is going to give us, and there's a couple of choices we can use for the method to deform, two methods to model: inverse distance, weights the deltas from each control point as the inverse of the distance to the control point. That way, the closer control points have a higher weight. Mesh deformation uses an affine transformation. Okay, so a lot of sort of high-end mathematical stuff. This inverse distance is going to give us a pretty good fit. Because so for the points, the closer the points are that I measure, the tighter the fit's going to be, basically. And then so I'm going to say okay, and it's going to ask me now pick the origin of control point one. So I'm basically telling it where in the image I want. So this corner right up here, I want that corner. Now, where's the destination? I want that endpoint there. Now, it's asking me for number two. So I'm going to take this corner right in here and put it right there. And let's see, what's something else that I can definitively see? Here's a corner here that's going to go there. Those other ones are a little missing. Let's see, I've got some things here. Let's see, this. Say from that corner right there, it needs to go to there. This corner right here needs to go to there. So, you would just work your way around and finding identifiable points that you can see for definite sure and place them. There's another good one. So that corner right there goes to right here. All right, so once you've done enough of those and gone around the site a bit, you just hit enter, and it's going to actually modify the placement. You might have seen the whole photograph shift, but it also warped it. But now when you zoom in, look at how those things fit. See, that's nicely done around the concrete there. My curb islands right here. Now see, I didn't show it those 2 points, but it transformed the entire image. And now you see how it fits it, almost like I traced it from the photograph. Okay. So that's a nice little feature. A lot of people don't realize that CADNet will do that. And that's really only,
So there was one spot where I think you picked wrong.
oh, where's that? Which one did I?
Um, go down further. It was one of the curb points right over in there. See that? Um, the middle
Oh,
of the screen
it was
bottom.
this one right here.
Yeah.
Yeah, I think maybe I did. Yeah. Oh, yeah, yeah, yeah. I should have been over. Should have been here instead of here. Uh, that's interesting. See how it did. Yeah. So what I would do is go back and I have to clear that whole thing out and then redo those over again. Yeah, you're exactly right. And that would have fixed that. But that's why it's a little off in that area. Same thing here. It threw it off. The closer I was to that error point on the transformation, the further it threw everything off. Okay. So anyway, I'm gonna take this image and get rid of it just so it doesn't hog up our drawing here. Um, but that's a nice little thing that CADNet can do for you. Now, if we take a look at this as a model, or what we would do to start to build our takeoff model, we can see a couple of things right offhand. We see that this building outline is supposed to be at this elevation 818.70. This pad here, this concrete pad, is supposed to be at, well, you see that just says 17.56. All of these elevations out in the parking lot are 17. So they've dropped the eights. So all of these numbers are supposed to be 800 and whatever else the rest of that number is. All right, but then if we take a look, if I just select that building outline, there's a couple of things I note immediately by selecting it. I look at my grips and I see I've got the square grips on the endpoints and I've got the little flat dash grips on the midpoints. So that tells me that that is a 2D polyline and it should have a single elevation. And hopefully it would be at 818.70, but I look in my properties. And if you don't have your properties up, you can just right click, go to the bottom and choose properties. But I look in the elevation field and I see that it says 0. So I could then, okay, I know what it's supposed to be. I could type that in and that would set that elevation accordingly. Okay, I'm going to not do that at this point. Same thing here. This one should be at 817.56. I see it has no elevation. All right, well, so I start to suspect that things are not as they're labeled. I look at this, what is a contour line? It's supposed to be at an elevation of 818. If I select it, I see it too is a series of lines, actually, not even a polyline. Oops, let me get rid of. So if I select that one and I look, and it's because it's a line, it's not a polyline, just made it's each of those individual segments. I have to look at the individual endpoints. So there's 818. And the next endpoint is, that's 818. So that one is actually at the right elevation for that. But what about over here? This one is 815. So some of these are at the right elevation. Let's take a peek here. 810. Well, it would certainly be a little more useful to have these as polylines instead of individual lines. So apparently it's got some elevation. But these spot elevations around my design are not elevated. And I really am not so sure that I trust everything that I see with these contours either. Okay. So are you familiar, Philip? Do you use your 3D viewer much?
Yeah, when after I build a surface, I'll look
Yeah.
at it in the
Yeah. So one
3D.
of the things that, yeah, one of the things that I like to do is to look at my drawing just to get a sense of what might have elevation and what doesn't. And you can do that by, let's say if I just choose this top corner of my little view cube over here, that puts me up, and I can also hold the shift key, press and hold the wheel, and I can do this. And so now I can see, well, everything down there at the bottom looks like it was at 0 elevation. There's something here that was at, looks like about a 19 elevation. I don't know what it is exactly. Oh, it's that, looks like the island that if you look at it in plan view, see that was that central parking lot, and it's got a non-zero elevation. I've got a couple of things down here. Looks like that has a negative. All right, so if I go to, let's look at it, say straight on from the front. So I see most things are at 0, but I've got a couple of things that are hiding out at some suspicious near amount. There's something not quite at 0. Here's something that's up at looks like 17.0937. And if I look at that, I bet that's one of the, yeah, so it's not even, so that's at 17.0937. I see in my properties, but it's not even, you see the label is 16.5 and 16. So, you know, there's some issues with this drawing right off the bat that we need to fix. And so what I typically do is I like to look at this in 3D. And I either do it here, or if I go back to my top view, I can do this and go to my 3D viewer, my drawing viewer. Of course, that gives me that. And it's not a surface, so it's not colored in, it's just line work. But so I see that the contours appear to be at elevation, but I've got some other things down here that are also showing up. And they show up because I had this switch over here that says ignore 0 elevation. It's up in the right-hand top. So if I see, like, if I don't ignore it, I can see where those came from. So there's one. Now, if I do ignore it, I can see everything else is zeros, but those are not. So I could probably figure out, let me go here and turn on. See, I've got this bounding box. Let's get labels. So I've got, you know, my elevations up here like 822, and then it goes all the way down to like near 0. Turn those numbers off, just box only. All right, so I've got some issues with my data, and, you know, I can use this viewer as a way to figure out what I've got in my file. So I could do a number of things. I could go to the settings tab of my viewer and choose this button here that says set the CAD view to the current view. When I do that, it says it's now set. When I exit, it puts me in that view. Okay. I could also use this cube, and I could just hold the shift key and press and hold the wheel on the mouse and move it around while I'm holding those down, just like pressing and holding normally does a pan. If I hold the shift key on the keyboard first and then do it, it does that 3D roll. Or I could choose actually to look at it through one of these horizontal faces. So I can zoom in here and I can see some of these things that are not there. But there's another even easier way of doing this. If you've identified some things, you know that they're not necessarily where they're supposed to be. You know the ground around here is supposed to be in the 800 elevation range, okay? So let's go to the file menu and let's choose drawing cleanup. And now, while this has all kinds of other useful features, I'm going to hit the clear button so everything's cleared. And then the only thing I'm going to check on is this set elevations outside range to 0. And just as a check, now these numbers that you see down here in the ranges are left over from the last time the command was run. So I'm going to say scan the drawing. So it's going to look, and I immediately see that, I've got a couple of just little fluky negative elevations, so they're not right. And my max is 822. Well, that's good. So, and I don't think there's anything over 100 feet in vertical extent in this drawing. So if I know my max is 822, I'm going to say anything, I'm going to give this a minimum of, say, 700. up to um, well, let's just call it 850. We could have left it at 822. So anything that is outside of that range, 700 to 850, it's going to set the elevation to 0. It doesn't erase it, but it puts it down at 0 so that it's not going to contribute some errors to my terrain model. So I'm going to say, okay. And now it says select the entities I want to process. I'll grab them. And it says, okay, I took care of 22 entities outside that range, set to 0. Great. So I'm going to come back here and look at it again from the edge. And I see, wow, look at that. Everything down here is 0, and everything up here is at its normal elevation, which would just be these contours. Now, the other issue that I've got with these contours is the fact that some of them are sort of incorrect. Look at this right in here. Can you see that? Let me see. The easier thing would be to do, we do this. Set that color. And I'm going to draw a 3D polyline. Sorry, let me try this one more time. Draw a 3D polyline. I don't care what color. I don't care what layer. And I'm going to go from the endpoints all the way down the ends of these contours. So this represents, the edges, or, what would be a line down that bank of these contours here. I'm just doing this for visualization purposes. And actually that was supposed to have been that color, but eh. All right, well, that's fine. But now if I use those to help me visualize those as edges, do you see how they don't line up? So the tutorial that I showed you in that tutorial manual doesn't even address this anywhere. It just takes the numbers and runs with it. But that's a source of error right there. There's a couple of other things over here as well, where if you do 3D polyline, what's it? I think I know what's here, but we'll see. Again, to help me sort of visualize this as an edge, and then, well, look at that. Wow, see, that's quite a bit of difference. And actually, technically, this should be there. So you see that is a discontinuity. So you need to be able to identify places like that and repair those. And probably the easiest fix on a case like this would be to sort of just chop off these ends and just let it bridge the gap internally. So you might have something like this. Let's go up to this one. And then this guy would be, let's say he's going to go away. And so now if you look, oops, like I missed one of those. There we go. So then if you were to take this edge and let it span up to this edge, then those little, the brown ends of the contours in between would go away there. These would basically go away, and then that would just connect them up so that they're not, you won't have that vertical discontinuity in there. So it's just a couple of techniques that can fix some things. Some other things are like right here. If I look at that, let's go back to plan view so I can see it here. I've got, this is supposedly a contour line at 817. And here's one also at 817. So it's the same elevation, but they cross. There's a couple of them in here that have some other problems. Here's one that is at 815 and it crosses this one, which is at 815, 815, 815. So those are all there, but they cross. So this is a pretty sloppy drawing, right? And there's not a whole lot, and you would find maybe some more discontinuities over in here. There's some real issues there along the, what's supposed to be a little ditch or something. So it's a bad example of data to be able to use because you've got all of those issues. Okay.
Yeah.
But that's just, that's some of the thinking that you need to apply and how to go about to fix those kind of issues, if it even matters, because you can actually model this stuff with those errors and live with them, knowing that, well, hey, you know, based on your experiences, you know, hey, that's going to be, you know, 3 wheelbarrows full of dirt. I don't care about that. Particularly if you're just going after getting volumes, you know, particularly to do an estimate. You don't care. You're not going to worry about it all that much. But again, if you're trying to build something, you know, with, you know, AMG controllers on a dozer, for instance, you don't want that
Yeah.
surface that you give it to have a little blip in it because the
Right.
computer will faithfully try to build that blip, right? So now,
How
uh,
about could you think we could take a break?
yeah, I was going to say it's right at our break time. That was going to be the next statement out of my mouth. So, so we'll come back to that and then pick that up. And so we'll sort of talk about next about how you assign elevations to your drawings to give me an idea of your workflow. So we'll do that. We'll take go ahead and have your full 15. Let's start back at a quarter till.
All right.
Uh, and we'll
Thanks.
go there. Okay. See you in a bit. Okay, so we've been looking at a couple of things that we can do to help us identify some problems and maybe come up with some decisions on how to fix them. Um, for right now, I'm going to get rid of these little things I drew. We're not going to necessarily go through all those efforts, although we squashed our things down to 0. Now we do have some problems right here. How familiar with the concept of what break lines are you?
Um, I mean I know what they are.
I mean, here's where what I'm getting at is if I take let me just draw a 2D polyline for here. And I'm going to say right down from here, I'm going to run up this little valley. Okay. Oh, why my colors aren't going on so well. And now I'm going to add some points to sort of help define this a little better. Let's put one out here, maybe one a little further out. And I get a little back in.
What command did you use there?
This is simply adding a point to a polyline. And what I did was I went up to my toolbar here. This is my polylines toolbar, but the
Mhm.
command is under Edit, Polyline Utilities, and it was done here to, I've got edits and removes, and under edit, I can add a polyline vertex. Okay, that's the very same effect as running p-edit and inserting a vertex and doing all those weird things. But it's a little easier to do by using that command. And so when you do that, pick a polyline to add to, and if I pick, say, this one, it shows me where those points are, just these little temporary blips. But then wherever I click a point is where it's going to add a new polyline vertex, right? So
Yeah.
I'll undo that. So now, um, and now there's multiple ways. Like look like this one, I was a little bit too far out. I can just grip at it.
Yeah.
And this one, I'm going to bring that one more to there, to the middle, and you can also, as you hover over these grips, you can do various things with them. So if I select it, hover over a grip, and I can remove that. I can also, if I hover over a midpoint, or I can add a vertex, so I can do that. But see, I have to keep going back and choosing add vertex if I want to do it that
Yeah.
way. All right, so there's any of those methods would be fine. So now, and I would take this one instead of being there, I would go right up into the nose. So I'm sort of splitting the difference down there. But now look at what I've got. That's a 2D polyline, and it's still at 0 elevation. But these individuals, like if I take, if I go to my viewer, view, 3D view, drawing viewer, if I select just those, oh shoot, let me get all of them because they're pieces. Now I can see, well, okay, they're good. My box shows me, I'm going to turn that box off. And I'm going to go back to uncheck, ignore zeros. I'll go back to plan view. I don't see it. Don't know what. All right, so, but that is still a polyline and it's at 0 elevation. So I need to get that at the elevation that it needs to be to represent that that break line, which is, let's see, if this is, that is at 813, that's at 812, and that's at 811. So that's going to be a little valley bottom. Because if I don't put that in there, let's say if this thing is gone, when I go to build this surface, it's going to make triangles form across these gaps in here. And they're just going to be, they're going to be flat until they get down in here. I'll show you how to illustrate that. Are you in this same area in your drawing? Which
I
is,
didn't even open it up. I'm just
oh,
observing you.
oh, okay. All right, well then, so to show you what that's going to be, now the first thing I want to do here is I'm going to isolate those layers. Just my contours. And now I'm going to go to File, Drawing Cleanup. I'm going to uncheck that one. But I want to join line work with the same endpoint. So I turn those all into polylines instead of individual lines. Now I'll go back, turn everything back on. So now I've got that as a polyline. It's at 811. That's at 812. So, but I need to create this at an elevation so that it's 811, 812, and 813 as it goes along here. So the way I'm going to do that, now I could have done this. I could have drawn a 3D polyline and connected, these endpoints, but then I don't have anything in here in the middle that I'm snapping to. So I would have to interpolate those elevations and then snap it to that elevation, then interpolate all between and snap to that one. All right, so that's another way of doing it, but I find the easiest way to do it is like this, and even a couple of other nice things. If you start off with a 2D polyline, when you select those, you can actually turn some of these into arc shapes. That'll sort of help move this around. Maybe pull that back in there like that, so I could have, say, removed that vertex, turn that into an arc and get that same effect, or even let's see, let's remove that and make that whole thing an arc. So, oops. Let's remove that one now. Convert that to an arc. So you see what I'm doing here is sort of smoothing these out, and I'm just doing it with standard grip edits. These are just standard CAD tools. They're nothing to do with Carlson on that. But it's not necessary, just to show you a different way of doing a couple of things. Right? So now, how do I get the elevation all along that 3D line that should represent the bottom of that little valley? How would you do it if you had to take that line and put it at elevations? How would you do that, or do you? And it's okay to say you don't know if you don't, because that's what we're here to do, is to learn how to do it. But if you do that kind of thing, I'm interested to know your approach to see what might be easier, maybe.
I think I would probably draw the polyline and snap to the contour.
Like draw it as a 3D line and snap to those points.
Yeah.
Yeah, and that would work. Then you would snap to that one and it would read that elevation and set the elevation right there. But then when you pick out here in space, you're going to have to tell it on that command line that you want to interpolate until you get to this elevation, and then it goes back and interpolates. So that's perfectly fine to do it that way. But this is, I find this way a little bit easier for me, because when I put in a 2D polyline, I can manipulate it here in 2D until I'm satisfied with its location. Let me pull that in a little bit like that. And then if I want to give that elevation, I'm going to go to my elevate menu. I'm going to go back to my construction module now, and I'm going to go to this elevate menu, and that is now a 2D polyline, but I want to make it a 3D. So I'm going to say 2D to 3D, and I have various methods, and I'm going to do it by screen entities. So anything that it touches, it's going to set the elevation, and it will interpolate everything in between as well. So if I say by screen entities, I'm going to say I'm going to uncheck, well, I'm going to say ignore 0. That means if it crosses anything at 0 to ignore it. And I'm not going to change the layer name. I'll just do this. And you can choose whether you wanted to keep the existing polylines or not. Like if I had a bunch of 2D curb lines and arcs, like I've got over here in my parking lot, I would turn that on. I would keep those existing polylines so I can keep the arcs. Otherwise, it's just those little short stubby segments, okay? And then extrapolate end elevations means like right in a case right here, because it starts at 0, but then it hits this elevation. So if I say extrapolate ends, it's going to start this one up here. It's got a known elevation, a known elevation, a known elevation, and then it's going to push this out here at that, continue that slope and hit and set the elevation based on that extrapolation. So I do want to do that, and that's all I need to do. You can also use this box down here, use elevations of other entities, proximity entities, and you give it an offset distance. So if it's close to something, it can still grab it. But right now, I'm just going to do those. I'm going to say, okay. I read my prompts. It says select the polylines to convert. Well, that's the only one I want right there. I'm through selecting. I hit enter. It now says select 3D faces, lines, and polylines that I want to use to read. So I'm going to select this one and this one and this one, and I'll hit enter. And so now it says it converted one polyline from 8 intersections. And so I can look at that now. If I take all of these and just, oops, sorry. Let me undo that. Let me grab those and look at my viewer. Now you can see how it laid the elevations in as it crossed each polyline. And then like down here on the end, you see how it just perpetuated that slope. So it's now lower than the two sides around it, which is what I expected it to do behavior-wise. So that now would become a proper model of that little area. And to illustrate this, I'm going to just build a surface. I'm going to go ahead and isolate just those things. And I'm going to just build a surface around this little area here, just a real rough one. So I'm going to go to surface and triangulate and contour. And I'm going to give it a file name here, and I'm just going to call it EG-test. And I will ignore zeros. I will let it do its automatic shrink wrapping. We'll talk about that a little later. And then I'm not going to draw any contours. I'll make sure nothing's in my filter, so that's good to go. I'm just going to build a surface, and I'm going to choose this. And we'll get a couple of them on the outside edges. That one, that one, that one, and that one, say. And go ahead and get this one. All right, I'm going to say that. And now it built my surface, and I'm going to go to my viewer and view my surface this time. And there's my EG test. And so now, let me turn my contours off. But so what you see is all of these sort of flattened areas here. You see how some work, but some don't. And if I turn these, if I turn the contours back on, you see right in here, these triangles are, all of these triangles in here are all flat. They're all the same elevation. See right across that. And up here's another one where these are flat. Let's go back. Let's go here. Let me change the color here for a minute. All right, so now those purple contours are the ones that it thinks it has. That's the ones that it's displaying out of memory. But let's add in the original contours that we used to model the surface with. I think that one too. So that's where those contours are. But you see, going up between this contour and this contour and this contour, that should be a nice smooth little valley rise. But you can see, let me turn this surface completely opaque. There we go. And now you can see, maybe not quite so opaque. Let's give it a little bit more there so we can see through it. There, I can see those original contours a little better. So see, it's trying to make that flat in between that contour as it loops around on itself. And so it comes up to this contour nose right here, and it climbs very steeply up to this flat area, and then it goes up that way until it gets to here. And then it goes very steeply up to the next area, and it goes flat all the way up to the nose in there. And that's not what it's supposed to look like. Here's another example. If you go to the, let's see, where is it under this one? I want to do a quick profile. It's doing it under, see if I've got it this way. Yeah, quick from surface. I don't want to do it from surface. I want to do a quick profile from the screen stuff. Let me see. I don't think they give that to us under construction. That's interesting.
So
All right, so
you're trying to create a profile from a polyline?
no, I mean, I know what that profile is going to look like. I want to do it from the surface along that line. And so there's a command under Civil called Quick Profile. I'm going to do this from a surface file, and I'm going to use that EG test. And now it says pick a starting point or a center line or a polyline. So if I say P is a polyline, I'm going to pick this polyline right here. And now you can see, watch the crosshairs down below at the bottom. See, it comes up, and then let me zoom up here. And now you see down the bottom, it comes up flat till it hits right about there. Now it's going to climb up real quickly, and it's going to be flat all the way along in here. And then it's going to climb up really quickly till it gets flat all the way along in here, okay? Now, to illustrate the difference and the reason why we need these break lines is we're going to go back and make the surface again, triangulate and contour, and this time we're going to select and give it a file name, and we're going to call this EG test-2, and we'll say okay, and we're going to select these same things that we used before. And then in addition, we're going to use that little line that we're going to serve as a break line, okay? So we'll say that, it's built the surface. Now, when we look at the surface file viewer with EG test-2, you can see right here, this long sort of valley shape. See, that's where that break line contributed to the surface, whereas before it made it flat across long stretches of that.
Yeah.
You can tell that difference as well when we go back to our quick profile, and we'll use surfaces. We're going to look at EG test, and we're going to compare that to EG test 10 or EG test 2. Say, okay, we're going to do it by a polyline. We'll choose this polyline. And now you see the difference. The white line in the profile is the one when we did not use the break line. The
Mhm.
red line is the one when we did use the break line that we put in and we gave it the elevations. So that's what that's for and why that's useful. So here's the takeaway from that is, again, if you're doing it for just real quick volume analysis, you don't necessarily need to do that, because the way it works when it's computing volumes is that places where it is over, where it shows too high an elevation, will tend to balance out areas where it shows them to be too low. And so those equations, or those summations of those volumes, will tend to cancel each other out on average. So it will be close to the same as if you did it using the model. Now, but if you're going to try to build that structure, when you're building the face of a curb, for instance, along a parking lot, you don't want it to have these stair steps in it. You want it to follow the red line down here, because that's really the way that goes. See, it goes from the contour right up. Let me zoom in here. You see, when I'm in my profile view, I'm right there on the nose of that contour. Well, it travels down to the nose of this other contour right there. And if you follow the red line, that's what it really does on the ground. But you see, the white line is what it models as if we don't have the break line in there. When we just take our elevations from the contours, they're going to have these problems. They're called flat triangles. Okay, now there is a solution to that other than the one that you just saw, which was to draw these break lines everywhere you've got these nose-shaped contours. But I mean, you'd be drawing this stuff forever. You got to put one down here. You got to put
Right.
going back the other edge. You just would, and right in here, you need to put one all the way through there. So that would sort of take, too much effort to try to build. Sometimes though we need to, but there's another way of doing it that is close to working. It's not exactly perfect, but it has some good routines. And that is, let me go back to let me stick with that. If you go back to surface again, and we're going to triangulate and contour one more time. And this time I'm going to give it a file called EG test 3. And right down here at the bottom, you see that little section right here that says adjustments for source data of contours? This one right here is to minimize those flat triangles. So when we do that, it's going to do its best to recognize where it has all of those flat triangles together and not form them that way, but form them in another fashion. So if I turn that on and choose just the contours again, now this time without the break line, I'll go ahead and get these other ones and say, okay. And now it's built that surface. If I view that surface, which was EG test 3, see, it's even tried to fix, it's tried to fix some of that. And you can see, how it's sort of worked in here. It's not exactly perfect, but if you had 10,000 contour lines, it would be helpful. So now to compare using that quick profile, this time instead of EG test and EG test 2, I'm going to look at EG test 3 compared to EG test 2. and the 3 will be the white one. And so I'll choose my polyline. And so now you see the red one is the one with the break line. The white one is the one that we just turned the switch on to said minimize the flats. And you see it's not exact, but it's a whole heck of a lot closer than it was when we did not have that switch turned on. Okay. So that is what to do is if your source data is made up out of just contour lines to build these surfaces, you're either going to need to draw these break lines in where they go, or when you model that surface, if you do it with this, when you do it this way, when you're giving it a name and you're naming the surface and you're selecting the data, then make sure that that switch is on, which is this switch right down here to minimize the flat triangles. Okay. Now, one other way to look at some of this data, are you familiar on the inquiry menu, this drawing inspector?
Yeah, a little bit.
Okay, so you could say display the, I'm going to just display the elevation. There we go. And so now as I walk, and I'm just hovering, I'm not clicking anything, but it's reading off the elevations as I go along that line. And I can see this one, that's 812 everywhere. That one is 813. That one is 812 also. This one is 813. That's 813. Then there's 814. That's 814. There's 13 again, 14 again, 12, and then 14, and it comes to 14 and 14. So this comes around here and really does this, but you can see it's a bit of a mess in there. So, you know, there's problems with this data, a lot of problems that I would fix before I would try to model it. Look at this in here. I mean, there's a contour line, it's 817, that's 817, but so is that. And that's 16, that's 16, so 17 is sort of the top of a ridge. And then what's this? There's 818, top of a ridge, there's 17 again. All right, so that's then 18. So, you know, it's like I said, it's not real good data. There's 18, there's 18, there's 19. So, you know, a contour doesn't just start in the middle of the air. You know, it goes from, say, this 18, and then that's 18. So 18 comes around like this and comes up here, and it goes up here and sneaks its way back out and comes around somewhere till it gets back to here. So, you know, it's, like I said, it's pretty sketchy data that you would need to fix to get some things going on. All right. So, so let's take a look at some of these other tools that we're going to be using. So we talked about adding this break line and also turning on that switch. So I'll just get rid of that one. But see if I restore all my layers. Now we've got the problem here of instead of, and again, this green line is a 2D polyline at elevation 0. Let me fix my units here. I've got should it work? That's better. Shows my elevations here to the 3s. Okay, good. All right, so instead of trying to set this parking lot edge as it crosses these contours, which wouldn't be valid anyway because those are existing contours. So I really need to sort of, I'm going to freeze those existing contours. And now I've got, might as well turn off these layers too. All right, so now I've got basically a bunch of elevation marks, right? And so how do I set those? So if I look at this as a 2D polyline that represents what's going to be an edge in my parking lot, I need to set these elevations. Well, I've got top of curb and then FS, which I have no idea what that might stand for. Let's see, top of curb. So it's half a foot under. It's the flow line. I don't know what they mean by FS. It's the face of curb. So there's really going to be two lines in there at the top of curb, and then the FS line is going to be the face down on the parking surface, right? Now down here, they call it flow line. I don't know what FS means versus FL, but I can see that the bottom numbers are the lower ones, the top numbers are the top ones. So I really need two polylines in there, one to represent the top and then drop it down and represent the face. Okay. So I'm going to also pull this guy back to there just to give it a snapped point. So what we have to do is to see if we got a tool to be able to read those numbers and set those elevations. And as it turns out, we do. So, but we only have one polyline. We can't give the polyline itself two different elevations. So we have to actually set 1-to-1 set of elevations and another one to these other elevations. Okay, so what we're going to do is we're going to offset this polyline just a wee bit to give it that face. So it represents basically the vertical face, but we, you know, it can't be directly underneath it because when we go to model it as a surface, a vertical surface will not be allowed. Whoops. I meant to do this. Let's see here. Let me set my URES up. There we go. So, so what we're going to need to do is to create, since it is a 2D polyline, we'll go ahead and just offset it. And put that back to, oops. So we'll offset it just to the pavement side, just a little bit, just like a half a tenth. So if I offset, I'm going to go to my edit offset, and I'm going to do offset to a layer. And I'm going to give this a layer name called, let's see, there's PR, that stands for proposed. There's face of curb. So I'll call it, I'll put it on gutter flow. So PR gutter flow line. And I'm not going to do both sides. I'm just going to give it an offset amount of just 0.05, just half a tenth is good enough. I'll say okay. I'll select this guy and I'm going to choose this side to offset. So now you see that offset to that side. That's the line I'm going to do the other one. I'm going to do the same thing for this one. I'm going to go over to here. And now let's see if there's any other places. Looks like that made it all the way around. I see yellow. Okay, so we're okay with all of those. All right, so we now have a top and then the bottom. So we'll finish that command and be done. Now let's elevate these two lines based on these text elements. So what we're going to do is, let's see, we need to know some layer names. So I'm going to go to my drawing inquiry and let's look and see. We've got a layer that is PR-ELEV. Looks to be the leader is on that. And PR, and the numbers are also on that. Okay, so that's fine. PRELEV, those are good. I'll now turn this off again, and let's go through and elevate that. First of all, we'll do the top of curb. So we will say, we'll go to our elevate menu, 2D to 3D, and this is going to be by text with leader. So it wants to know, first of all, we'll look at some options here. Oh, for options, we'll give it a tolerance of, let's give it just a, say a 10th, doesn't matter. And then we're going to select a sample of the elevation text. So there's the elevation text and a sample of the leader. So I'll pick one of the leaders. Now they're both the same layers. And you'll see what happens when it comes up here. It says, now select a sample of a polyline to convert. So I'm going to zoom in here and select this line because it's all on, and it's, I don't have to go get all of them. It knows to find everything on that same layer. So now I'm going to say, that's the sample that is going to convert. Now it wants me to select the ones that I want to convert, the leaders and the elevations to process. Well, I can just go out here and grab everything now. And it's only going to work on those things that I've selected. But notice, remember our text was all on the same layer. So we say, okay, and wants to know an elevation to add. Remember we had that 800. So we'll add 800. And now here's what happens. It recognized that there were, so your selection set contains text with a number of different suffixes. So I've got FL, FS, PAD, and TC. Well, the TC is what I'm selecting right now. So I'm going to just move that one over. That's the only one I'm going to use. It's going to ignore all these other ones. Okay. And I'll say, okay. And so now you see it's come up here and it's identified one that's it's red outlined here because it's a possible problem. It says there's a conflict detected. Pick the polyline corresponding to that current leader. Because it doesn't go all the way up to it, I'm going to say right there. So I picked that and it cleared the red. I'll say in for the next selection. Okay, and now it went through and everything got selected and elevated. So if I look at that now back in my elevation, you see what it did is it's put all of the top of curb elevations in all the way around for that green outline. All right, so I'll go back to my top view now. And it also, let's see, what layer is it on? Oh, you know what this layer is? It's changing the colors of these right now because of a setting I've got. Let's go to my takeoff and site net and let's turn off these assign colors. And then I'm going to turn everything on. I'll select everything and set their color to be by layer. There we go. Now, let's go back now and isolate again, or let's freeze all of these unnecessary things. All right. So now we've got the one is elevated. The green one is elevated. The yellow one is still down at 0. And you see, here's an example of when it converts it to a 3D, it has to use those line segments. It can no longer hold that as an arc because there's no such thing as a 3D arc. As it changes elevation, that has to go with those segments. So we could have kept those originals on a separate, on their, on the separate layer, so we could use those later. We don't need them, so I'm not gonna worry about them. But here's something to also keep in mind. You see how, if you can imagine this yellow, in fact, let's go ahead and offset that back. We'll just do a standard offset of 0.05, and let's put this guy back to here. All right, so there's the original arc that was there. And you see those green segments is how it approximates that arc. And if I look at this distance, I'm going to do a standard distance, and I'm going to go from this midpoint, and I'll go perpendicular out to the arc, and that is a distance of, wait a minute, I need to do it in 2D. So I'm going to draw a 2D. All right, so that now has a distance of 0.026, okay? If I take a look at the length of that, I see that length is 0.783. All right, so sort of keep those numbers in mind, and that is something that is set here in my Carlson configure, general settings. It's over here on the right-hand lower corner, and this is how it removes arcs. I tell it I want to either use a maximum offset or I want to use a chord length. Whichever one I choose is the one it's going to be using. I like this maximum offset, and I'm saying I want that maximum offset to be 2/100ths. Or the chord length would be 0.5. Now mine was like 0.78 or something like that, so that's not the one it used. It would make them shorter and they would be even closer. If I made this maximum offset a smaller number, it would keep that maximum distance there tighter, okay? So just keep in mind, if you ever need it, if your 3D line conversions are winding up going from, instead of something like this, which is close enough, maybe it comes over here and goes boop, boop, and it just has two little straight lines and it doesn't really follow the curve. You need to tighten up those numbers that's in your Carlson configure general settings over here in the lower right-hand side. All right. So that's what's going on with those particular ones. Now I'm going to erase that thing that I did. So that one's now elevated. Now let's go back and do the same thing for the face of curb line. And we did that, remember, from the elevate menu, 2D to 3D by text with leader. So we select a sample of the text, a sample of the leader, a sample, now a sample of the polylines to correct. So that sets the layer. And now it wants you to select all the polylines and leaders and elevations. So again, instead of going and picking them individually, I'll just pick them all and let it filter it out for me. An elevation to add 800. And now we had the TCs already. So TCs we don't want to use. The pad is probably, one of these in here, I think, which we don't want. So really we want FL and FS both to be used. And we say, okay. And looks like it did not have any errors. It didn't find one that wasn't close enough like the first time it did. So now we should see two lines elevated. And there they are. You've got the green ones, which is the top of the curve, the yellow one, which is the face of curve. Now I see I missed getting these two islands. Another good reason to look at this stuff in 3D is because you can identify places where you've missed a couple of things. Now there's a couple of things to notice here too. First of all, I see that line for that gutter is a dot, dot, dot pattern line. So I'm going to go to my layers and I'm going to change that particular, which was PR gutter flow line. Instead of that particular line type, I'll just make it continuous. There we go. And so now you can see something else that's happening here. You see how this green line walks around the top of the curve and then it starts to go down and it matches and then it comes back up. So that's a depressed curve right there. And you can see it also right in here where it drops down and it comes back up. So that's where it's putting in. There's another one up here near the entrance, I think. Yeah, right in here. You see how it drops down and then climbs back up? That's where those numbers, and most of the, here's another place where it drops down and then it climbs back up. So that's where those tops of curves did not stay a consistent half a foot above. It drops down and then comes back up. All right, so, and again, here's another place where it does the same thing. And you can see that, we'll go back here to our top in those areas are like, right in here, there's a top of curve of 68 and a flow of 66. And here's 1710, but 1660. So that's half a foot there. So it drops down and touches it almost and then climbs back up. So that's a bit of a depressed curve in there. And there really should be, this same elevation on around here a little bit before it comes back up. They didn't label all of them in there, but that's all that we have. Now, we did not do this one. We got the top of curve, but we didn't get the offsets on the inside. So we need to fix that one and this one. So when we do that, we've got that. We'll go back to elevate. Oh, I'm sorry. The first thing we need to do is to offset. And we're going to offset to a layer. And again, we're going to put it on that proposed gutter flow. 0.05, we'll say okay. And we're going to take this little curb island and go to the pavement side of it. Now there's that one. We'll go over here. We'll grab this and go to the pavement side of it. And there's that one. Okay. So now we need to convert those two new lines we created to have elevation. So we'll say elevate 2D to 3D by text with leader. And we go through here and we select, first of all, read the prompts. Oh, sorry, I've got to escape the one command I had going. Now, elevate 2D to 3D by text with leader. Now, reading my prompts, select a sample of the text, a sample of the leader, a sample of the polyline to convert. And now, which ones do you want to convert? Well, I'm going to just limit it here to I'll get all of these. I got that one, and I'm going to go over here now and get all of these. So I don't want it to bother trying to look at those other. it's not going to bother these over here. So that's all I need. I'll do that. It's now, I'm going to give it 800 feet to add. And I want these FLs and FSs and say, okay. All right. So now when I look at this in 3D, I see that indeed there's my top of curb and my face of curb. So that looks good. So that's ready to then model. I could model that. And here you can see that top drops down and then starts to climb back up. But see, it drops down to a single point and starts coming up. It really ought to be flat and then come up again. But, you know, short of knowing where those points are, you know, I could say, take this guy down to there. So I can do something like that. And that would be more like what that should look like. But again, I'm not gonna, and the same thing like right in here. That should probably do that, but then I would have to interpolate all of these. So I'm not gonna go through and fix all those. But if you did, you could just, you know, find the corresponding points that these go to and bring them down like so. See here now, I want to. There. You know, so you could do something like that so that it then maybe, you know, pull that one there. Let's see if what that looks like. And then maybe leave that one there and then to interpolate those in between. So another way of fixing that would be, and notice I've got a little bump in there. Let's see, if I went to my elevate and I did my polyline elevation editor, I could do it this way too, where I select that, I get a bunch of points. And now I see some things that are marked as reds and blues. And the red ones represent control points and the blue ones are the float points. So if I select this point right here, wow, and look at this profile. See how it jumps up and down? Now it's in a fit condition, so it's, you know, those are not necessarily, they're not that radical a jump, but they do jump. So where I am here, if I set this point, I'm trying to see where my point is. Settings here a minute. See if I label control points. Okay. Look at there. I got a problem. me get out of this a minute. Fix that. So I've got a point here that missed. Yeah, it should be. Say in there, it went down. Let's see. All right, so the depressed curb is right there, so it climbs back up. I just need to bring that up to let that interpolate. So if I do my elevation editor, see in my labels. Oh, I know why. Need to be in top view here, so that would be around here. There we go. So it goes from there, goes from here to here. And then back to 8, down to 4, 34. All right, that's okay. Where was I looking at that? It should be 1815. Here I've got 2. So I want to take this and uncheck it, and take that and uncheck that one. Oh, you know what I did? I pulled those in. So I really need to pull that back out so it matches the offset. So do here. Offset that's selected. So I want to offset it at 0.05. That's selected. Offset 0.05. Oh, it's just offsetting vertically. I need to bring that back up to that. And so that elevation there is 18.1. That's good. And that one is 18.1, also good. Yeah, see, I should have put that there, and that should be 1826. So if I choose this, point number 3 should be 1826. So if I select that point and then pick the elevation. Or pick a point or pick elevation text. So the elevation text is right there. So the 1826, good. All right. And then
It didn't add the
Same.
800 to it.
say again.
It didn't add the 800 to it. It just changed it to.
Oh, yeah. Thank you. And I need to do that same thing here. I need to pull this. What am I going to do? Number 4. I want to move that vertex to there. And now 17. So if I select the 4 and give it the 1742, I want to pick it from here and then I'll add the 800 to it. There we go. So, I'm not going to go through all this mess and try to fix those areas that I missed because where did it? It was wherever I missed placing it. I shouldn't have snapped down to that location when I was rotated because it moved it. Here's a case right there where this should still be back here. So if I select that and move it to here, and then I should have done the other one back here. So again, I'm not going to chase these all around, but that's the process that you would do to set up those as these 3D edges and such, and it would build those. Now, if I look at this in 3D, ignore my zeros. Like right in here, you can see how it does drop down, but it still should be at that slight offset. And it's not, it's a little too close in there. And it drops down as a flat entrance across the front of the building and then comes back up. And then there's other areas over here where we should have brought this one down right there to have that as a handicap entrance. Got some issues over there as well, right in there. See, that should be back a little bit. See, let's get this. Actually, what I should do is go back and just re-elevate it and not screw with that. But anyway, we'll leave it as it is for now. Oops. So, but that's how you set the elevations on those parking lot edges to be that elevation. Now, another way of setting elevations too is you can simply, you see that pad is at 81756. But you would just simply, let's see, because it should be at that elevation. So we just select it, come over here in the elevation field and add or type in 81756. That's perfectly valid to do that as well. Now you could take this one and do that the same way for this building pad, or you could again do that 2D to 3D by text, not with leader. Pick a sample of the text. Whoops. Pick a sample of the text, pick a sample of the polyline, and now select the things you want to convert and the labels you want to use. So that's just those two things. And it asks, all right, you want to set a different elevation, keep the originals. And so if I keep the originals and I can set the elevation, and I'm going to put that on 3D dash BLDG just for yucks. And even if I don't have that elevation, or even if I don't have that layer, it's going to build it for me. So now I've got two things there. You can see as I start to rotate the one, what happened? Let's go back and repeat that. Elevation, a sample of the text. So it reads 718, okay, sample of the line to convert. Okay, now select the lines to convert and the labels. Keep the original set layer for elevated. Elevation to add to text values, none this time. And say, okay. All right, so now how many do I have here? Still just the one. That command is not working. Got here. Just the one, but set it. So what happens if we now select the ones you want to use? What happens if we don't do this? Well, that command's broken in at least this version, because that should have given us that option, given us that elevation to read that, because it recognizes the number is 817.70 as the elevation to use by text. Select a sample of the elevation text. Select a sample to convert. Now select the polylines to convert and the labels. That one and that one. All right, let's put this on layer 0 just for yucks. All right, now that one did work. Huh. Let's see if that layer has to be pre-built. If I call it 3D-BLDG, and let's make that green. Now let's see if we can do it. This one is still at E. So if we select a sample of the text, sample of the line work, lines to use, we'll keep the original, we'll set the elevation on 3D building, we'll say okay, Remaking polyline 1, but it still only gives me one polyline at 0. So do that again, select the text, select the building. Now select both, and this time not keep the original, but set the elevation to that layer. Huh. It's still on layer pad, and it's still elevation of 0. We do the same thing but this time we put it on layer 0. It seems to work. No, it didn't that time. These are they're the only ones that are frozen. Building. Does it have to be completely visible? There's the text. There's a line. There's the line in the text. And keep the original. Okay. Now I see. Oh, if we apparently when you do this, the entire line that you're going to convert has to be entirely visible on the screen. So you'd have to zoom out to make it work. So in this case, if I run this command, I choose the elevation as a sample. That's just a sample. These are what I'll convert. Now I can keep the original and also put this on 3D building and say, okay. Oh, no, it still missed it that time. All right, so if we do that, and then we do this and this, and not keep the original, but set on 3D building. Okay. Apparently keeping the original causes it to break, and it has to be completely visible. So now I've got this on 3D building at elevation 818,700. Very interesting. All right, so now everything that has elevation in our drawing indicated has been elevated. The pad is at 817.56, the building at 817.70. Okay, we brought all our parking lot edges up. Everything's good to go. Now, we are right at our lunchtime, so that would be a good place to stop and take our break. So we will, I'm just going to save the drawing now, and then we'll come back and talk about the takeoff approach to doing this modeling, how we're going to use these layer memberships to create these materials and come up with that information and see some of the automatic surfaces that we are going to generate as a result of that. And I think yeah, that should be it. Okay. So we'll put a bookmark there. We'll save it. I'll pause our recording. Our recording back. And hope you had a good lunch break. And so we'll pick up where we left off. We were discussing some ways to elevate some line work that we have in our drawing. And we're going to talk about building surfaces. One of how we typically do it when we select the items that are going to be built. They're going to be part of our surface, and they can be anything with elevation, any kind of 3D lines or elevated polylines. They're 2D, but they're not at zero elevation. So anything like that, that would include contour lines, building footprints, all of those different types of things. So we have enough right now to take what we're seeing on the screen and come up with a surface of this built design. That would be our finish grade, our design grade. The other thing that we have are these contours that represent our existing ground. So if we isolate those layers, so if we isolate layers and we get some of these, make sure I'm getting them all. So this would represent, and again, we'd have to, make sure that they are elevated. We can verify that with our 3D viewer. And indeed, they have elevation. You can see it there. And we already talked about these little problem areas over here on this bank. Looks like they were done from, different compositions to make those particular pieces of this surface. So ignoring those for the moment, let's talk about how we go about defining these surfaces. Now, if you were doing this with, say, the let's see, I'm going to go to my construction module. And if we were doing this the non-takeoff way, where we're just going to be selecting information to create our surfaces, we have those contour lines as our existing surface. And so we would need to make a surface there, call it existing, and then we'd make another surface to make it our design. So if we isolate, again, I'll get these contours, make sure I get some of these. depression contours. Looks like I got them too. Okay, so now we've got enough information here to build that surface. And we would go to our, we don't actually, we have a surface menu. So we can triangulate and contour. Now, by doing this, we're going to make a surface out of the things that we select in our drawing. And we're going to give it a name. So we're going to triangulate and contour. And we're going to look at these various options. We could draw the surface contours that the computer is going to generate. We already have some drawn contours, so I don't really need to draw those. You can draw those at any time as long as you save the file. So you write the triangulation file. I'm going to select it, and I'm going to call this demo1-EG for demo one existing grade. Okay. Now we're going to come down here and look at our shrink wrap perimeter reduction. And that has to do with if we have like areas that are not defined, it gets rid of those long skinny triangles out on the edges. The shape of this is going to be fine as it is. So we don't really need to worry about that so much. So we'll leave this on a medium setting, and we're not going to draw our bounding edges there. We do want to make sure that we ignore our zero elevation. So if we have something that's down at zero, it's not going to pull down that surface down to the zero elevations. And remember, we talked about those nose-shaped contours, the little valleys and the ridges and stuff. So this is a case that you're going to run into when you are using contours as your source data. So you want to minimize these flat triangles. So we're going to turn that on. And we're going to say, okay. And now it wants us to select the points and break lines to triangulate. So we can just grab everything. And off it goes, and it has created a surface with no errors mathematically. Now, there are some errors out here with these weird things. So let's take a look at that surface, our 3D view, surface file viewer. And there's our demo EG1. And you can see, well, it sort of represents things. Now, I would look at this, for instance, and I would say, well, you know, this is really smoother than what the contours have given me. But that's really all the information I had. And you can look over here and see, like right in there is probably a problem. Over here's that one problem area that we saw earlier where those edges didn't match up. And it sort of just fills in the gaps, okay? And again, you can decide whether or not you want to try to resolve that in the data or not. So we're not going to take the time to do that, but we saw some of the techniques that we could use to do that with. Now, if we do this again, I'm going to show you the difference in the two surfaces. We're going to make one now called Demo EG1 with flaps. And I'm going to uncheck this box right here, minimize. I'll say okay. I'll grab my data. It built it. I'll look at my surface again in the viewer. And now you can see you've got a lot more of these little flattened areas over here. You don't have that little, you see that right there, how these little stair steps come into play. So that gives us some additional error in our model. Now, if you want to compare that to, say, the other one, I'm going to go to my model tab and I'm going to load up the one that we said to minimize. And then I'll turn the one with the flats off. So there you can see where it minimized it. Now I'm going to turn the EG that has the flats. So notice those flats right in here. Compare that to that one. So you see it's smoothed this out a little better than that one. Made it all a little stair-steppy. All right. So just remember when you're building those from contours to always have that switch on. Or alternately, you could draw in the break lines that say connect up these noses and all of these noses, and you'd have to get the top edge, the bottom edge, the next top edge, and all of that kind of stuff, and draw those in ahead of time. All right. Alternatively, you could have the data that created these contours. If you had a bunch of survey points and a bunch of edges, that's really the better source of information to use, but we often don't have that. So we've got those two surfaces, one with flats, one without. We'll use the one without. That's our existing ground. Now we could save that as our existing grade. Now, when we do this the takeoff way, we're going to look at the takeoff surface. And we have to go through a number of steps to be able to create this existing ground, these make existing ground surface and make a design surface. So to make an existing ground surface, we have to, and I can go ahead and turn back on all my controls. So the first thing I need to do is we need to give it we have to draw a boundary around everything to begin with, because we have to define that boundary. So I'm going to go to my draw menu and I'm going to choose a command called shrink wrap entities. Now don't confuse it with this boundary polyline. That's a regular CAD command, and that has to do with hatching and filling of closed areas. So we're going to do this shrink wrap entities, and we'll let it go across the gaps because we want it to close across these open areas out here, and it instead of jumping in to try to find the next line. So we'll let it go across the gap. We're going to put it on a layer name called BDY-10. That's our boundary of our triangulated irregular network. And we will say, we'll just give it a low reduction. This time, make it a 2D. We'll say okay, and then we'll select the data that we want to shrink wrap. And there it is. That has become our boundary. Now we would come back and I would probably, take, remove a couple of these vertices out to try to open this up a little bit more. And then let's do that, so I could do something like that. And then maybe come in here and add these back in to come back around up here, like maybe turn that into an arc and let it close up a little. So you get the idea. But that's not going to do much for us. So now we've got a boundary made. Now, one thing you can do is on this takeoff menu, the very first item is a project checklist, and this tells you things that you have done and things that you still have to do before you can calculate some volumes. Okay, so we'll do that. Now, it said that the boundary was done, but it had used this as our boundary. But that would be the boundary for the design surface, but we really need to incorporate these areas out here because you can't just build up to this line and leave it hanging in space. It's got to go down and find this existing ground as a target. So we're going to change that boundary. So we'll go back to the takeoff menu and we're going to come down here to the boundary polyline. We're going to set the boundary polyline. Do I want to clear the existing boundaries? Yes, I do. And I'm going to now select that boundary polyline. So it's now done. It was done before, but they'd used the other one out here. So now with that as a boundary, we have enough in our menu to next go to, we have to define the layers that make up our surfaces, including any materials with it. So if I define the layers, I'm going to get this box, and I have 3 different types. I've got existing entities, design entities, and everything else. So from my everything else, this other, I can come down here and find like index contour, index depression. I don't need the labels there. And then an intermediate contour and an intermediate depression. Those are my contour layers. So I select them there, and down here, you see I can choose that they're going to be existing, and I'm going to hit the move button, and it's going to move their list over here to my existing entity. So that would be what makes that existing surface. Nothing in design yet. Everything else is other. And we'll talk about another nice feature of Takeoff that helps you keep track of all these things in a minute. All right, so we've got that as our existing surface. Now, I'll hit the save button and exit. So now I have done in my project checklist, see I've got my set boundary polyline, but it tells me my define layer target is missing. That's because I haven't set that for design yet. Okay, but I've got enough to do the existing ground. So if I go back now to my define layer surface, I could go through there and pick those layers from that list, or I can come down here and choose this set layer for design, and it lets me pick it from the drawing. So if I set layer for design, I'm going to come down here. It now says set the final layer, select entities for the design surface. So it's going to be this one, and this one, and my building, and my pad. And that's basically it. Now I don't have to select all the things. I'm just telling it the layers that it's going to use, and I can check that by, again, looking at my, see it says that I'm now done. And if I go back and look at what I've defined under Takeoff, define layer, I see existing and I see design. It has 3D building, proposed face of curb, proposed gutter, and my, whatever that is, PRLCST. I don't know what was on that, but that has probably this one here. Let's see. That's on layer PRLCST. You know, who knows what it means, but I was able to pick the things from the screen. So now, with everything defined as being in its layer membership, I have enough information that I can go to Takeoff, and I can come down here and make an existing ground surface and make a design surface. So if I make an existing ground surface, it went through, read everything on the layers, and made the surface. If I come back to Takeoff and say make design surface, it goes through and makes everything on the design surface, but it had a couple of problems here. It had some vertical edges, and that would be, if now notice it says 0, so it says there's no difference in elevation. And let's say if I were to be able to find it, I'll tell you where they are. So I'm just going to exit because I don't have any listed. They were under the tolerance, but those were those things that I went through. And remember when I snapped down here and they're stuck on top of the other line. So it's vertically right over top of the other line. So that is going to give me an error message that I wouldn't normally have gotten if I did that part correctly. All right, so now we have those surfaces made, but notice it did not ask us for a surface name. And that is set here. If you go back to settings and look at Carlson configure, which is the third one down, and then we look at the Takeoff and SiteNet settings button at the bottom. Right here in the lower part of the bottom section here is what it's going to use to build surfaces. It's going to put suffixes on a name, and the name is going to be the name of the drawing. So you're going to see a bunch of surfaces now called Demo 1-OG, ZEEX, BSZN, and FN. And those stand for, this is the original ground before any adjustment. If you've added any subgrade zones, like if you've had the geotech information, it would take out those other zones into that surface. And then if you've removed those zones and also accounted for the topsoil depth, you can have differing topsoil depths in different areas. It makes one called EX. So that's basically the existing ground with all the stripping applied to it. Same thing on the final design surface, you've got a BS, which stands for base. Now you can make those anything you want, but by default, so that stands for your base design surface. Again, after any zone, so that's ZN, whereas the other one was ZE for zone existing, zone for design. Why they didn't use D, I don't know. And then afterwards, you get this, after you've accounted for the topsoil replacement and any zone stripping for the subgrades, it comes up with an FN, which you can think of that as final. Okay, so those are going to be the surfaces that we now have. And if I go to, say, view a surface, you can see in here, I now have my Demo 1EX. OG was the first one. I didn't have any zone influences and no topsoil, so OG, ZE, and EX are going to be all the same because we didn't have any of those changes to apply. Same thing with, I've got the Demo 1 ZN as our final. There should also be a base, a BS, and a ZN. That's with the zone. There's our final there.
The BS is above the
Oh,
EG.
it's up here. Yeah, there it is. So those three are all going to be the same. But we're going to look right now at our final surface. And this is, and you can sort of see in here the shape of, you see how it did all that? It stepped down the curbs and it's got the, you can see the curbs are real nicely defined. And you can see even where I've come down here and brought those depressed curbs down. Let's go around to this side. And you can see over here how it came down and met and then started to climb back up. Now there's a thing over here. You see how it comes out of this exit from the parking lot and it has this long thing here because we didn't close that off. We just let it, that line just ended here and the line ended here and then it extrapolated all the way out to the boundary. Okay, and so that's another switch in the settings. I'll show you that here in just a second. Same thing happened like right in here where the top edge of this parking lot just goes out and seeks the boundary. It interpolates out to that boundary edge, okay? So if I say exit to that, and let's look at that setting, go back to Carlson configure, takeoff and SiteNet settings. Right here, if I uncheck this, extrapolate to the boundary perimeter, and here's that minimize flats, by the way, where you turn those on. And now if I say, okay, I'm going to go back and just with that one switch changed, I'm going to go back to takeoff and just simply remake the design surface. Off it goes. There's my error that I can't see because of this. The settings sensitivity is not small enough. And now if I view that final surface, there's that Demo 1 FN. You can see how it only goes up to the edges of the last thing that it found on those layers. And it did not extrapolate out to that perimeter that we set. It chopped it off. Now it filled in these little areas here because we didn't wrap it with a boundary. But it only goes out to that to this defined edge and stops. Okay, so that's why it's probably in your what you call your best practices to have that go out there and create that. Now, another thing you can do is if we come up here and let's close off this one edge so that ramp doesn't get built. So if I'm going to draw a 3D polyline. I'm going to go to draw 3D polyline, and I'm going to place it on a particular layer. I'm going to select, or I'm going to pick, and the layer I want to pick is this one right here. Okay, and so I'm going to say okay now, and I'm going to now pick that elevation, and it reads it down here. You can see it. I'll come over here and select that elevation and say enter. So that's now closed off. It's a separate polyline, but we can join it here in just a minute. And so next I'm going to trim off these little ends just a little bit here. So I'm going to say edit break, and I'll just say select an object in second point. So I'm going to select right here and jump out to the end of it. I'm going to do the same thing over here. So I'll repeat the last command. And now I'm going to draw a 3D polyline. And this time I'm going to put it on this layer. I'll take that elevation and that elevation. So now I've got the edges, but I also want to go ahead and close these off in a single element so that it's not just this one around to here, but it also includes this one that's the same, that should be all the one wraparound container. And do I have any other? No, see, that is closed off right there, but it wasn't up here. So I'm going to go to edit, and I'm going to choose join nearest. And I'm going to say I'll just directly connect the endpoints, and I'm only going to join identical elevations and only join identical layers. Say okay. And now it wants me to pick the entity. So if I do that, I did a crossing so that I selected the yellow, the green, the yellow, and that's also got them selected over here. I'll say okay, hit enter. And now when I select this, I look at my properties and it is indeed closed. Okay, same thing would happen for that yellow. So now, let's see, did I change back? Okay, I still do not have extrapolate the surface to the boundary turned back on, because what that does is it extrapolates that surface all the way out to the edges, regardless of what the slope may be. It just goes out that far until it hits that edge. And that may be what you want to do. Or now that you have this line as that outside edge of the curb, we can actually do some 3D offsets to put that down at a specific slope. So if we're going to put down, say, 2-to-1 side slopes from the back of this curb, or let's put a little 5-foot buffer out here that's going to be flat, and then we'll offset that one. So in that case, you're already familiar with your 3D offset. So we're going to go down here to our edit menu, and we'll choose a 3D polyline, offset 3D polyline. So we've got all these different methods. And so the first one we're going to do for that one is we're going to go by interval. And we're going to say, okay. And it's going to ask us now for the horizontal offset amount. We're going to make that 5 feet. And the vertical offset amount, we're going to leave it at 0. And so we're going to take this outside edge and select that side. And so now there's a 5-foot flat buffer all the way around our parking lot. And we could come in here, for instance, and get rid of this little jump up in here. And we would do that by going to Edit, Polyline Utilities. We're going to remove functions, and we're going to remove a polyline segment. So we'll remove that one. We can go ahead and remove that one too. And we're going to, now this one, I'm not going to remove that segment because that would take that whole segment out there. But what I am going to do is I'm going to extend this till it hits over here, and then I'll trim this one off at that line. So I'm going to choose right click, extend, and it wants me to extend, select the boundary. So there's the target. And now select the one I want to extend. Right there's that one. Okay. So now I need to break this one off here or trim it. So I'll say right click, trim. I'll select this guy, and then I'll trim off this part of it. And now, just like in the parking lot, we want to join nearest. So we go back to edit and join nearest. And we'll say this one and this one. And now when I select it, I see it goes all the way around my parking area, and it is closed. And in fact, I could do that same thing. Oh, I've got a problem right there. It didn't. It didn't follow that exactly. So what I would do in this case is I'm going to remove that polyline segment again. And I'm going to since this is all, let's see, this is at elevation. So I'm going to draw a 2D polyline this time. And I'm going to start here. And I'm just going to come out. And then go over to that corner. Now maybe square that up a little bit more to where these are a little bit more parallel. All right, so now that's a 2D polyline, but I need to set its elevation from here to here. And remember, we did that with our elevate 2D to 3D by screen entities. And we'll say, okay, it wants us to select the polylines to convert. So that one. And then select the things we want to read. So I'm going to read that, and I'm going to read that. And I'll say enter. And now this is now a 3D polyline that has that elevation and that elevation, and this elevation is the interpolation between the two. So now I'm going to join nearest, again, this one to that one. And the way this command works, whenever you choose this, you choose the last one that you choose is the layer that it's going to go on. Otherwise, if I chose the green one first, it would go on whatever layer that is. So I'll now choose that and then choose that. And that should close it all. Oh, something missed. Oh, I need to uncheck this identical layers because these are on different layers. So I'll choose that. I'm going to join to that. and say, okay, now we've got it and it's closed. Yes, indeed. It's a 3D polyline. So now I've got 5 feet basically, and you know, I could have just drawn this across here. In fact, I'll do that. We'll pick this, and I'm going to go from here to here, and I'm going to use that now to trim. There's my target, and then I'm going to trim out. Did I miss? No, should have been. Huh, it's not doing that. Let me try a different command here. If I break by crossing polyline, the clip edge will be this one. And now the polylines to be clipped is this one. And now that's by itself. So I can just delete it and go back to join nearest again and get this and this. And now again, it is closed. Yes, it's a closed pad. Okay, so you know, you could make little adjustments to things like that. We took out that little sliver. You could, you know, put these little triangle areas in over here and there. Same thing over here, or we just leave those like they are. That'll be fine as well. But that's the kind of adjustments that you could make to this, you know, if you're fine tuning the thing. And so now we've got that one. It's set 5 feet off of that back of curb, same elevation. So now let's offset that to seek the existing ground at a specified slope. So let's go back to edit, 3D polyline utilities, offset 3D polylines. And this time for an offset method, let's choose surface. Okay, and so we'll say, okay. Do you want to round the exterior corners? Sure, we'll do that. And what slope format? Let's do it by ratio. And we're going to select that green polyline that I just did last. We're going to choose the surface that we want to offset to. And that's going to be our demo one EX. That's the final resulting existing. And now it asks us for the slope ratios, 3-to-1. We're going to go with just 2-to-1 so we can see it'd be kind of steep. And if it's in fill, it'll be 2-to-1. If it's in cut, it'll be 2-to-1. And now which side? We're going to go to that outside edge. And there it is. So this line, which is on that same layer, and I want to change those layers just to illustrate a couple of things here. So I'm going to go to my layers list. I'm going to make a new layer called, let's just call it 3D offset. And we'll give it a color that we'll recognize to make sure that we're there. So we're going to select those two polylines, and we're going to change its layer to 3D offset. And so there they are. Now, if we were to view these in our 3D viewer, you can see the back edge, which is flat off the back of curb, then goes and seeks at a 2-to-1 either cut or fill to where, see, like right in here, it's a cut. Back here, it's a fill, where it ties itself down to the existing ground. Okay. And so now, if we, and we have to add those, we have to add that layer now to our design So we go back to takeoff and we set layer for design. So we're going to pick one of those. And so it now is in our design tab. There's that 3D offset. Okay. And so now when we make design, make a design surface, and it gave me one vertical edge there that was big enough to find. Ah, right there. So what happened when I trimmed out that little thing and just extended and trimmed at that edge, that's not at the same elevation. And I can tell that when I go right there and I just sort of, let me spin it up here so we can see it. There, you see that little vertical edge. So what I needed to have done there instead is I need to have this point up here meet at that point there. So I'm going to make this edit by selecting this. I'm going to take that grip and I'm going to snap to the midpoint of that segment right there. And then I'll take this one and come back down to there. So I now have brought that edge down to where it's all on the same point. Now there's vertices there and they're stacked right on top of each other. And that's okay because they have the same elevation. Now I'll go back to my plan view and I will go back to takeoff and make my design surface again. And now you see I've only got the one that's hiding somewhere with that curb work that I did. And now if I view that surface compared to those two that we looked at, this time it's going to be my demo 1 FN, my final. You can see it goes out. There's that 5-foot buffer from the back of curb. It goes out and then it seeks that existing ground to where it cuts it off. Now you see this stuff in between here. If I look at those as just, these are these long skinny triangles that these triangles in here are probably not valid. And we can fix that by, instead of using this as our perimeter, we can now use this as our perimeter. And that's all that we need to consider because we know our design is going to fit within that with 2-to-1 slopes. So if we were to do that, then we would simply go back to our takeoff menu, boundary polyline, set the boundary polyline, clear existings, yes, and now select the new one. So now we go back to our project checklist. You see it says we've set the boundary polyline, but we need to update because the boundary changed on these two. So we'll now go back to takeoff, make existing, it's done. Takeoff, make design, it's done. Again with that little error that we can't clear out. And so now when we see those surfaces, we look at our existing, which is our demo 1 EXE. Now I'll turn those back on. So that only goes out to that line, and you can see the areas that would be in cut and the areas back here that are in fill. And if I view the final, the same thing, you see it's coming out. There's your little offset, and then it goes down and immediately to where it finds the existing ground, it stops and it no longer fills this stuff in here. Like it, you remember over here, it had those long triangles because we had that other surface out there. That, I mean, the other perimeter. So it tried to push it out to that perimeter. So now that we know where that design actually has to touch down, we can use that as our new perimeter. Here's another case out here where it's actually in cut. So it goes up there and stops, and then we've got that nice little 5-foot perimeter around there. And here's a case, it comes out 5 feet and it has to climb all the way up here to make that existing ground. Now you could do something to fix that if you didn't want that to be there. If you wanted to grade that out, then you would make that boundary out to here and then let all that stuff get resolved when he goes to build that surface. Okay. But that's basically all that we needed to do, was to set those up based on layer names and then tell it to compute those two surfaces. Unlike when we built the surface with triangulate and contour and picked those contour lines, and we gave it a specific name, using this takeoff method, we can choose things that are on specific layers. Now, that's another little warning message, is that you need to make sure that things are on their proper layers. Because if I said, all right, I want to use everything on this contour layer, and you happen to have a building that's drawn on the wrong layer and it's on that layer contour, it's going to try to use it. So that's a nice thing to do, is to maybe, as you're getting started, go to your inquiry menu and choose layer inspector, and then just start walking down your layers. So there's one called 3D building. That's right. Here's one called my 3D offset. That's right. There's my boundary 10, which we're no longer using. My image, which nothing on it. There's my index contours, my depression contours, and you can do more than one, by the way. Let's see. Let's get all of our index and intermediate. My mouse is losing track here. Let me see here. Anyway, so you would, and there's your intermediate depressions. There's your pad, which I thought there was supposed to have been something on pad. My curve, back of curve, my face of curve, my gutter flow line. There's that PRLCST. Not sure what that's supposed to represent, but anyway, as we scroll through all these, you can see the different, that's not, oh, okay, PRLCST.
PRLCST was the
That little,
cool
that,
area.
yeah, that little pad in the front of the building. So, we just use this to sort of identify and verify that we had things in the right layer. Because sometimes, if you're not aware that something might be on the wrong layer, it could be a problem. So that you're not aware of that it's going on, and you need to resolve those. All right, so now you have everything defined in two surfaces. And so what you would do as the next step is, if you go back and look at this project checklist, you've done. Now your total volumes are not done yet. So if I go to takeoff and choose calculate my total volumes, it's going to ask me for cut, shrink and swell factors. For cut and fill, you can report tonnage if you knew the densities, et cetera, depth zones, all of that kind of stuff. We'll just take it as such. We'll say, okay, and here's now our volume report. It shows us our existing surface. That's that demo 1-EX. Our final surface is the dash FN. So we've got, 4,900 yards of cut, 2,700 yards of fill. And here is a nice little number to sort of look at and get from these reports. And it's in this block right here, because we've got what it does in this average block is it takes all of these numbers up here and it computes an equivalent rectangular prism that it has an average depth of 1.9 feet in cut and 1.3 feet in fill. There's your ratio and your export volume. So we're going to have to carry away because our cut volume is higher than our fill volume. So we've got this export volume. That's the difference in those two numbers. But right here's the two keys right here. We would have to take our design surface and raise it by half a foot or 0.458 to make those numbers balance. And it tells you for every 1/10 of a foot, you're going to get 474 cubic yards. So we're going to raise it up, 4.5 tenths, and that will get that 4.5 times that number should give us this number right here. Okay, so that's a good number to sort of keep track of, and you could do this a number of ways. If we wanted to raise that 0.458, remember that number, we're going to make it higher. And we could take our design surface and raise it by that amount if we use this command here called triangulation file utilities, where we would load our demo FN, color that in. And let's go to the next screen. And we're going to add, so we're going to add a value all the way around there. So if we add a value of 0.458, say okay. So we've now done that to this surface that's inside of here in memory, and we have to come over here and do a save as. And if I call that my demo 1 FN, it's going to overwrite that. Now I'll go ahead and exit this. So I've now raised that final surface, that 0.458. So now if I go back to calculate my total volumes, you're going to see that number is getting closer to 0. See right there? I only have, so I've got 3816.7 versus 3815.9. It's essentially, I've balanced that. So it tells me I need to raise and lower by 0.000 feet to get there. All right. So that's how you can use that number and then bring all that stuff up like it was. And we raise that and then save out that new file. Okay. So now, to keep from using that new file, however, because I want to use these same numbers that the designers came up with, I'm going to go back to takeoff and just make my design surface over again. And there's that same little error. And I can verify that by doing those total volumes again. And you should see that same 2,000 and some yards of export. Okay, so now I'm back to where I was before. And you can see how easy it is because I don't have to go out and constantly pick the elements that I want to use as long as I'm doing it with this defined list of layers. Okay. Now, this also gives us some additional information. If we look at our design tab for a minute, and we've got a building, that's their 3D building there. And you see over here under report and depth, the depth is nothing there yet. But if I double click that, or select it. Can I choose edit? I don't see an edit button or edit layer. Yeah, you could do the same thing, either edit layer or you can just double click it. So I'm going to now tell Takeoff how to treat that or all the elements that are on that layer. So for my 3D building, I want to, yes or no, include it in my material quantities. And I can give it a material type. It is an area type. And I can give it a cost per square foot if I know what that is. I can come down here and give it some subgrades. And this is where the power of the Takeoff way of doing things is going to give us beyond what we could do with the pick the elements method. And if I adjust the target surface, that's that final grade, by these subgrades, this is going to be those zone adjustments that we get. So we're going to use depth units. I'm going to switch that to inches. And you can say use a vertical from the pad to the surface. So it makes just a straight walled vertical cut. Or you could use a layback. So if you're, putting a basement in here, for instance, it can be 8 feet deep, but you could lay it back at a 3-to-1 side slope, or, all kinds of different things you could do there. So we're just going to use this vertical. And let's give it the subgrade name. Well, we're going to call this one our conch slab. And it's going to be, let's say it's a pretty substantial building. We'll make it 12 inches. Now, I don't have any idea how much things cost, but how do you pay for concrete, for instance, by the yard,
Yeah.
cubic yard?
Yeah.
And how much does that cost? Let's say
Mm.
it doesn't, you don't have to be, I mean, just say $17, or $17.25. I have no idea. That might be orders of magnitude off, but let's say
Probably 170.
how much?
170.
170,
Yeah.
$170 a yard for concrete. Okay. And you could have a density if you knew what that was, say, and it can give you tonnage if you were looking at that as well. That won't be any problem. All right, so underneath that slab, though, we're going to have, say, a stone base. And maybe that's 18 inches of stone, and maybe we're going to buy that by the ton. And that was 120 for crushed limestone. I don't know. We'll call it $25 a ton just to give it a number. And you could put all kinds of different things there. That's enough for that one. We'll say okay. And now look at we've got face of curb, and we've got, which is not really the face, that's the top of curb, but that was the layer they had named. And we've got this face of curb here. Now, what it's going to do is it looks at that face of curb, which was the part that was inset inside toward the parking surface. So underneath that, if I look at that one again by that area, this is going to be the subgrade name. We're going to call it let's call it asphalt wearing course. And let's say it was 2 inches of asphalt. And how do you buy asphalt? By the yard or by the square foot or
Um,
a ton of asphalt? And let's say it's, I don't know, 50. I have no idea. Um, and then underneath that wearing course, we've got, let's say, a binder course that half inches, and this will be a little bit cheaper, say 7 inches or $7 a ton. And then we've got a stone aggregate, or let's call it stone base. It'll be the same as under the building, but that's only going to be say 8 inches. And that'll be by the 120 pounds for limestone. Like 20 something that we might have a sub-base, just a well-graded aggregate or a mix. And let's say we had 12 inches of that, and we paid for that by the cubic yard at $15 a yard. All right. So now we've got that in their flow line. We look at the actual top part of the curb. And we could say that that, instead of being an area, it could be a linear feature, or it could be a back of curb / pavement. And then you could do that same thing here for the curbs itself. And we'll just say it's a 6-inch, we'll just say concrete. Well, just leave it as concrete, 6 inches. Again, by the cubic yard, you said 170. All right, so now we've got all that defined. We'll say save and exit. And now we look back at our checklist and we see that we need to update. Now, the ground surface, we haven't changed anything on, so we don't really need to update it, but to clear your checklist, you would. And so it doesn't hurt. So we'll just make the existing, and we'll go back and now make the design. And again, it's going to come up with that. Okay, so there was some perimeter that, oh, something's not closed. Let me exit that. That's closed. That's closed. It's closed. That's closed. I miss one of these. Closed. 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 I don't see it. These are all showing as closed. Let me run that again and take note of the coordinates. All right, so discarded a perimeter polyline at 6135132, comma 2189969. And then it gave us another one at 132 and 968. Same location. So to find where that is, I'm going to just draw a little 2D polyline. And where it asked me to pick a point or a point number, I'm going to type in those values. I had 613, 5132, comma 218, 9969. And so right there, it's where it finds a problem on a perimeter. That is closed. These are both closed. Huh. It discarded something in there. Well, not sure. I think there's something with the geometry being so tight in there that it has eliminated that. Let's take a look at our surfaces now. So if I view that surface, let's look at the final. Now you're going to see something different here. Whoa, I see. You see what that has done? Look how deep that parking lot is, or the
Yeah.
pavement areas. Now, why is that? Let's go back to takeoff, define the layers and the materials, and let's look under this one. See, that's 30 inches, but this says 6 feet and 24.5 feet. I forgot to change that to inches there.
Right. 0.5 and
Same thing here to inches. And so now we should be in a lot better shape.
hmm.
And we also had this guy, that's that pad in the middle in front of the building. And let's just give it an area. We're going to just call it, just going to make it a slab on a prepared grade with no base. And inches, and that's going to be, let's say 8 inches. And again, concrete at a cubic yard at 170. And say, okay, save and exit. Now we rebuild our design. There's that little problem again. And then to verify, we're going to review it again. And now that's looking a lot better. So now you can see the depth that it put in here for all of those different layers. And there's the building pad, and there's that little pad out in front of it. So it's accounted for that. Now, if I look at that compared to, say, the original, which is the BS layer, and then I turn this one off, it still had that drop down because that was our the difference in those two polyline edges. Don't understand why it's got, all right, the pad. Why is the building? That building should be, there's a face in front of that building for whatever reason. Let me see. It's just one item. Now that should have formed triangles across here. That's the base. I make design. BS. Huh. That actually should not have happened like that. Let me try something here. If I make the ground again, I've made the existing, I made design. So let's look at first the base. and then the ZN. And then the FN. So I've got yeah, no, see, that's got the building cut down into the ground. That's the final. Whereas the base shows this building elevated a little bit. So it steps down off the building onto this level and then off again down to the parking lot. And that should not be happening. It's as if there is something. That's a 30-inch depth underneath, but it's giving it like a 6-inch height. And really it should go from here to here. So the elevation there, if I look down on my command or down at the status line, it's 818.7 and this is 817.36. So that should be sort of ramped up from that corner all the way up to that edge, not out flat and then up. So why is it doing that? And if I take a look at my surface viewer, for instance, let's see if on my surface menu, I want to look at my surface inspector, not my surface viewer. I don't see it under here. Switch to civil a minute, get that surface inspector. And let me load. Oops, reload. Maybe it'll prompt me for it. I'm going to set the file. There's my base. Now, if we can watch this, if I get right in here, I'm at 818.70. That's what I expect. And as soon as I step off the edge into the parking lot, I'm at 817.37. And see, that changes. And it should. See, if I'm right in there, it's at 1694. 1744, that's correct. And then it should go up to not 1747, but 1870. So there's something that's causing that.
Are there two lines there?
That's what it acts like, but there's not. If I cross that and I look up here, I see there's only the one polyline.
And the elevation is right.
Yeah, that's 1870.
Yep.
Well, that shouldn't be. I don't know what to attribute that to unless, let me go back to my layer definition. And let's take maybe turn that off for a minute and see what that does. See, it's still. All right, so that wasn't it. So if we design, we want to do that anyway. That's because the target is, see, import templates, subgrades. No. Now that fixed it. See, it goes from the edges here up to the building edge, but it also did not, it doesn't have the building in there at all. Because it tried to lay back the edge. And that was where I said use vertical. Yeah, see, I don't think that these little errors should be causing that in the computation. Those should still not be causing that to sit perched like that. That's, and see that little pad out here should have the same behavior if there was something to it. You see, that pad there became just part of that surface. If I view the final, you'll see the pad and it's incorporated its depth. So that's the way I'd expect that pad to be. And the building has its depth applied, except it should be 30 inches. I think it was. See, 30 inches of total depth. And if I look at my surface inspector, and instead of this, let's use the final. when I'm inside the building, 816.2 versus 18.7. See, there's 18 out on the ground. So it goes up to 18.7 from there, 18 to 18, 816.2. Yeah, there's something that's pulling that down in there. So 816.2
That's
to
2.5 feet, so that's that 30 inches.
that's your 30 inches, but right outside of it, it should be like 818.7, and it's 817.9, so it's 818, so it's 7/10 too low right in there. That's where it raised it up and dropped it down. Wow, I don't get that. Well, if I take this off, I had a concrete slab of 12 inches, stone base at 18. That was 170 and 25 cubic yards, tons, 120. So if I remove these, and then look at base, wow. Um, I think it has to do with this back of curb line, maybe. If I go to my layers, let's put that back for the building. We had a concrete slab, 12 inches. And we had the stone base of 18 inches. And then this one where we said 6 inches, I bet that's it. Because we gave it this. But we told it was the back of curb. So let's put our curb dimensions in here. We'll go just take this type 1, 6-inch top, 18 total. 6-inch height, 12-inch, so it's 6 inches deep. That should be okay. A taper, let's make that a 0.1. was 170 cost per cubic yard concrete. Still. All right, if we look at, what was their other one? The ZN. All right, so that's the, it's not the full depth. It's just taking, there's something. Huh. Uh-huh. Now, see, that still should be, how much depth did we have on the parking area? And the building should still be 30 inches. And the parking is only 24 and a half. But if we look at that final, parking lot looks right, 24 and a half, but the building's not at 30 inches deep. Let's see here, let's include, adjust, use vertical, 12 and 18. It's an area. Two, 4.5, 24 and a half, that's right. So that part works. It's that back of curb. See this line here. It treats everything inside it, and then it finds the building, and it should remove that from, so it's building curb to curb, and then it's finding the building and it's picking it up out of that building. Whereas the inside curb face runs into the back of the curb, so that influence stops that from going across, but it does come across to here. So it fills in all of that. So there is the fact that we've got a closed polyline that's inside this other closed polyline. So if we take the back of curb, or the face of curb rather. We said it was a back of curb. Let's not adjust the surface. Let's see what that does. Ah, we no longer had that other error there. Now, look at the BS. Still. How does it raise the building up? We'll do the final now. It's still not getting that full 30-inch depth there. The parking lot's behaving fine for the driveway.
Well, it is getting the 30-inch depth. It's just what's from the building to the curb is not graded properly. Is that what it is?
Yeah, that's the way it's looking. See, if I put those triangle edges on there now, see that, and this is the way that should create those. It should go up to that perimeter, that outside edge, and then does the drop down on the inside. All right, now this surface that I'm looking at is the final surface after everything's been accounted for. So the parking lot has the drop downs. Those are fine. But it's this that comes here from the back of the curb, and that hits here on this bottom line, which it should not. It should hit up here on the top, not at the bottom. Where is that
Well,
bottom?
that's inside the building. Those triangles are
Oh,
inside
yeah,
the building.
yeah, you're right there. Yeah, okay, so this one, that's okay. What surface am I looking at? Let's see here. I'm looking at the final. So it does look there, but I don't think that's 30 inches.
Does it have to do with the grading of the curb?
Well,
Because your subgrade inside the building is right. 816.2. That's 30 inches lower
yeah,
than
but as soon as you
18.7.
step outside the building, that should be right at 1870, and it's 817.40. If I look over here at the back of the curb, see that's 816.97. So it climbs up a little bit. Yeah, the subgrade's fine there. Now, what about out here in this parking area? So that should be around 1686, but it's 1481, so 2.5 feet below 86. So 2.5 is 1430, so it's 1480. 2.5 should be 1736. So
Yeah,
that's,
you're 24.5 inches of subgrade for.
yeah, so that's right. But it's the visual that is here because it's showing out here as 1620, which is correct in terms of numbers. And then it's coming out here, and that outside edge here should be 18.7, but it's too low. And when I look at just the base,
What's the top of curb right there?
where right here,
Makes into that.
that's 17,
Wouldn't it tie into the lower part down
see,
below it?
that's 1736 right there, and that's
No,
correct
there's another point directly off that corner that you were hovering by,
up here,
down lower. And this, it's not in the screen right now. That point.
right
So
there.
that's 69.
Yeah, see, that's all correct. It's correct around the edges. It
But
goes,
now go back to the building corner. Yeah.
that should be 18.7. So this is coming across, it's trying to go from one edge all the way across, and then it hits these interrupters, and that's the way it's supposed to be. Let me take a look at these settings. And check that.
Didn't you input some information for the curb? Like you define the shape of the curb?
Yeah. I'll take a look at that here in just a second. Let's see, right here. So that curb was this, and we told it that it was a back of curb, and we gave these dimensions of such. All right, so let's just say it's an area instead of a curb. I wonder if that's causing it. Now, if we look at the base, why is it sitting up on a slab? These curves are working beautifully the way they were defined. You can see that depressed part there that, I sort of screwed it up a little bit, but this building, and you see this thing in here
Yeah.
is not showing. I don't think. Let me grab it. Oops. All right, so there it is. And if I look at the triangle edges, yeah, they do. See, that's the way the building should be sitting on that ground, just same as this slab is.
Mm.
So there's something about the building. It is at 818.7. It's the only item there. This is at 817.56. So if we look at the depth that we had for that there, see, it's got an 8-inch depth, concrete. That's fine. And then the building, you got these other depths, that's fine too. Adjust the target surface. by depth. What is that supposed to do here? This will interpolate the surface model out to your layer and then vertically adjust the model to tie into the layer. So that is what it looks like it's doing. So if I turn that off, now this one, see that had it. Let's look at the flow. Maybe. I don't want to get too I don't want to get too bogged down in this. I can't figure out what's causing it though. So if I look at the base, still a problem. That one, where that sits, is right on that, and that is the way it should be, but this should not be coming off. There's oh, wait a minute, let me go back now and look at the final for a minute. See, we turned that adjustment off on the final, and that's still sitting up. So that needs to be on. Let me turn that vertical on. Make design. Yeah, it's the strangest thing. If I look at the final. Okay, that little pad worked. And there's, see, the parking lot works. And the building shows some depth, but it's not. And yeah, when we do the surface inspector, the numbers come up right for this elevation, but it's this out here that's too low. So it's only going up to the bottom of that double stacked line.
I think it has something to do with the curb.
Yeah, so if
What it's doing with from the curb to the something, how the curb is defined is dictating what the surface is doing from the
yeah,
curb to the building.
yeah. So if we take the curb out, And then we look at our base. Not going to really. Yeah, see, it wasn't the curb that's causing it. There's something about that polyline.
Well, what about the elevation outside the building now? Outside the building line.
And see, there's now supposed to be that 30-inch base and it's not, or 30-inch down cut and it's not. There's something. Let's go back and put those. Remake existing just in case. Now we're back to this. I've got crossing break lines. It's not a crossing break line. Nor is that. It's a single polyline. That's a single polyline. That's two 3D polylines. Why is it coming up with these? I don't know. Let me try something here because it may be that it's trying to adjust those existing surfaces instead of building it from scratch. So if I were to take the get rid of these surfaces. Demo one. That's not part of anything. Let's see. Demo one. FN, OG, ZE, ZN. 1, 2, 3, 4, 5, 6. That should be it. So now All right, so that didn't. Still doing that. Parking lot still looks good, but the inside of the building is too shallow. That one looks good. All right, I'm going to save this drawing. And I'm going to exit this. I'm wondering if maybe,
I still think it's something in that curb definition.
yeah, I think so too.
Because we get all those crossing brake lines as soon as you put the curb
No,
back in, which
yeah,
was
but there's
something we didn't
nothing,
even have before.
yeah, but there's nothing there that crosses them. There's got to be geometry that crosses it. I don't understand why it gives me that error. So I'm thinking that maybe it's an error that's something is stuck in memory. That's I'm exiting and I'm actually going to um, the AutoCAD version here, and then maybe by resetting, it will. All right. Good. Now we no longer have the crossing brake line errors. Okay. Good to know. So now if we look at the PS, see those are, how big are my contours? 1 foot contours. So it's climbing up from that surface like a foot, maybe 2 feet. See, there's your 2.5 feet in the parking lot.
We're only
That building
we're
should
only
be,
24 inches in the parking lot.
yeah, that's true.
Well, 24 and a half inches.
1, 2, yeah, 24.5. So that's 1 foot, 2.5 foot. Yeah, so that one's right. But look in the
No,
build,
24 and a half inches.
yes. So,
Not 2.5 feet.
oh, oh,
24.5
yeah, 2 feet, 2 feet.
inches.
Yeah, not 24. And then 0.5 feet, it's 0.5 inches. Yeah. So 1, 2, so that's one. So if you look right there, that climbs up 1, 2, 3 feet right there. It climbs out. So it's pushing this down too far, is what it's doing.
As,
So if it's doing that,
that curb type one is a pretty complicated. That's like for a crazy slip form.
Well, if I did,
which has a 30-inch base and, well, it depends on what it was defined as.
yeah, we had it as a
Well,
6-inch top and 18-inch width. The gutter pan's 18 inches. The taper is 0.1. So it's just a tenth of a foot layback. The
no,
drop is 0. So basically it's flat gutter pan.
one,
6'1", 6-inch for the height 1, 12-inch for the height 2, and then the base should be 24.1. So let's make this 5.9. Makes that 24. See, that should work. Now looking back at that final again. Yeah, see, that's 1, 2, 3 feet out in here. So what is the problem? Let's put everything back to colors. So why is it doing it? I've got 2 things there. All right. So if we look at these curbs for a minute, this is the top. And let's just make it an area. No depth, no nothing. It's just going to be an area. And this, again, inches, that should be, let me set that settings. Let's turn off these colors here for a minute. Now let's make design. All right, so that's this out here in the parking lot. That represents that difference. But see, that's a foot difference right there. There shouldn't be. See, this contour shouldn't come up to here and start down and have this contour here. My contour interval is 1. Let's do 2. Make them half. See, that's showing a whole foot. And it's not. And this shouldn't be happening out here at all. That should be like this right here. See that pad sitting right there on that
yeah.
surface. And there's where all that mess went. Let's do this a minute. We'll go back to telecad version. All right, so if I load, let me come here a minute. Just demo one. Okay.
Want to take a little break?
Yes, I'm sorry. That's a good place to do it here. So let's um let's see you back in about a quarter after.
All right.
All right,
Thanks.
thanks. Yeah, thanks. I would have dragged you right through it. So I'll work on this and see what I can come up with.
All right.
So now what I did over the break was go back. I opened up the file brand new again. And okay, so we got some issues here. Uh, so I'm going to take these guys. I'm going to make that a control point. There is a control point. Now I'm going to set a bunch of vertices here. Let's see. And then move them like so. So this guy. Oops. All right, just a couple more here. All right, so that should work there. All right, so I went back and took the file over again from its new state, and I didn't do those weird things. And I just did a make. Did I just say make design? Yeah, now we no longer get those errors. And let's see what happened. If I look at the base, there we go. That's what I was expecting for the buildings. And if I look at it as the final, oh, I guess I haven't put the building in yet. Is that right? 818.7. So let's go back to layers.
I think it was on the pad layer.
Yeah, it was. Layer is it on pad? Okay. Yeah, because we made it by a 3D and changed that layer. That's what happened with that one. So now if we bring the pad, whoops, other pad, move to design. Now we can set the pad, and so we've got the curb like we always did. It will be a back of curb dimensions, that same. That's okay. The flow line is 24.5 inches. That's good. The pad now. We're going to have a concrete slab. We said 12 inches at $170 a yard. And we had a stone base of 18 inches at $25 a ton at 120 pounds. All right, no errors that time. Let's look at the base. Yep, that's good. And then once the base was done, oh, sorry, I didn't have to rebuild it, but Then we look at the final. Ah, darn it.
30 feet instead of inches.
Yeah. That's why this is so important to view this stuff, to be able to see it before you take off with it. Much better now. So there, it's cut down in. That's cut down in.
Curve still looks like it's deeper.
You know why? You know why that is? Because this line here is still essentially half a foot below this line.
Oh yeah.
And this is the line I applied all that material to.
Yeah. Yep. Yep.
So then that one is the upper line. So it's just it's the half foot on top of that that goes to the top of the curb. And
Yep.
this does all, has all that subgrade down. So if you look at that in the base, you'll see that half foot right there. So then it goes 24.5 inches below that. Okay. All right. So apparently, doing that business where I managed to get those things screwed up caused that to really have a problem. All right. So that being done, let's go back and look at our volumes again. We got a different report, and that's that this time now we've got this much to export instead of 2,000 because we're excavating down to that base grade now to be able to fill it back with some other material. So whereas the first time we ran it was just existing to final top to top.
Yep.
And if we also then did our material quantities, that should work. There's all the materials that we defined, the curb, 3,300 feet of curb. Why it gave us square inches, we could have, or square feet. There's our asphalt wearing course, the base course, the concrete, and the curbing. And under the pad out front, wow, it's $1 billion. That's not right. What's going on?
What do we? There's no way it's seven.
We got something. Let's find out what that was right quick. The pad 170 inches, 8 inches, $170 per yard, cubic yard. Oh, shrink factors. Somehow that got. All right, so our pad, shrink and swell, 170 then, it's fine, cubic yard tons, inches. The curb is just a back of curb. Okay. So we could, have a length, a linear foot cost on the curbing, and we would take that out if we wanted to. Well, here's a cost per length. I don't know how much, let's call it 12.50 a foot. I don't have any idea. And then we have this one. Shrink and swell, everything's okay there. All right, I think that'll fix it. So we save and exit, rebuild it. Now we look at the total volumes should not have changed. Yep, there's a 10,000-ish. And now our total, oops. Now our material quantities. That's a little more like it. So now there's our curb costs at $12.50 a foot. And concrete, now concrete is also included in that curb definition, I think. Concrete slab, the stone base, sub base. So the concrete for the curb was in the curb dimension. Yeah, see right here, I defined the material.
Mhm.
So it took that cost there, and it also took this cost up here so I would need to take one of those out of there. In fact, let's just take that out. Save, exit. Line. And then material quantities. Yeah, so now it's no longer showing it in the cost up here for the curb, but it's incorporated in this. All right, so knowing that part was good. Now, a couple of other things is you've got the cost summary report. The heck? Let's do that. If your cut volume, your fill volume, export, and the cost of materials. That's what, 11,000 yards there to 10.9 and 10.0, or 960 for fill. 11,000, so 10,000. There's my export. So at $1 a yard. Now I don't know how much does it cost you to haul a yard of dirt around. I'd say it's a different amount
Yeah.
than $1, but so anyway, that should do that part. Okay. All right, so now what we need to, here's that quick profile. So if I want to do a profile from, say, here across there, now we go. Now this is the difference from in the civil where we had we looked at it to try to show those differences with those stair step contours. This is a similar command. It's still a quick profile, and you can't resize this down here. You can just take a look. Now I can do it with no vertical exaggeration, or I can, give it a little bit of vertical to see. But you see the differences here over, if I'm looking at, these are the ones that I want to show, I've got the original ground. I don't have any topsoil stripping and adjustment. So I got the original ground, the design surface, and the final surface, final target, no over excavation or strata, anything like that, which can be defined in those other adjustments. But you can see now the white line that you see in the profile is the existing grade. The red line is that final target. That's the bottom of that excavation. And the yellow line is the top of the design grade. So if you look at like right in here, from here to here, there's that pad that's underneath that little island. Whereas over here in the parking area, you can see it's 24.5 inches deep there. And the top has the step up for the face of curb to the back of curb, to the top of curb rather. Same thing over here. It goes, the reds are the bottom target. The white is the existing ground. The yellow is the top of the final surface. So you see it goes from that pad right there up to the building, and it goes on a straight line increase. Okay, so this is all modeling exactly like we thought it would. Okay. So now the other thing you can do, if you, like I put this in with that, by picking points. So see this adjust alignment? If I click that, then I go up here and move this around. You see, I'm looking at this overall surface in real time as it's cutting it. And I can even, let's see, I'll put it down here and then I go back and adjust. And if I pick nearer the end instead of, and I have to do it each time I want to change one of the aspects of it. So maybe just looking at it across that line. So you can see what that all looks like. I'll adjust the alignment one more time. Let's go from the parking lot and then out across that island. And I can save that as a profile file. I can even draw it based on whatever these defaults are right now. I have no idea what they're showing up as, but there's now the drawn profiles. Why, where's my lines? There's my elevations. Huh.
Yeah, the elevations were off by like 500 feet. So does that mean that the lines are 500 foot below it?
Well, I did a zoom extents and it comes back to that. So it only
Yeah.
drew the grid. Let me take a better peek at the draw function. All right, so if I do a hood profile, and let's see, I'm going to pick, all right, so there's that. Now, if I draw that, all right, so I'm going to draw the grid, draw the horizontal axis, draw the road intersections. This works for road profiles too. Here it is. Let's make my horizontal scale. Let's see, 10. Just give it a 2-time exaggeration. '50 scale vertical 2, no. Make that 20. Make that 5. 4-time. Say okay, and now it's these numbers here that were causing it. That was set from another file when I did this with a road profile. So now it should work a little better. There we go. And of course we could, we'd have to go and see, this is on a layer called profile. I think they're all on a layer called profile. Yeah, we'd have to set, in those defaults, we can set those layer names and line styles and all of that. So we get all of this information here. So I've got an 815.6, which is profile general text is the layers. They're all different specific colors. But that sets, so I've got a 815.6, a 1611, and a fill amount of 0.53. So that's what I'd have to fill from here up to there. 0.53, that makes, oh, from the original, from the existing. So if this was green, that's our overall target. We'll make that red, and this is the top of the finish. All right, so bill of 0.53 to get from here up to that top surface there. And over here, you should be seeing some cut fill. Did I take something? Oh, it's like, it's in my prefixes. They're actually backwards. That should be a cut value. The F's should say cut. 6 feet. So that's, what are these? Every 800 to 1, 2. So that's every foot. So 6 feet. So 1, 2, 3, 4, 5, 6. Yeah. So that's that amount. I've got the order of what in the draw defaults, I've got the order. It's treating the existing ground as the final, and it's taking this red line as the existing ground and showing those fills to be that amount. So like right in there, you've got a little bit of cut right in there, but you don't see it labeled because it's only labeling every so often, every 50 feet. All right. So, with a little more care setting all that up, you could actually, come up with that as well. Now, do you do topsoil adjustments in your work?
No.
Do you ever plan to, like, do you have something in a spreadsheet somewhere that does it for you, or
No.
okay. Because what you would do basically is you would outline the areas, and then you would simply come here and say these topsoil removal. You would define your depths, and then you would identify those polylines that outline the areas of certain depth. And so it makes those adjustments just like we did for the depths of these pads and such. Okay.
Yeah.
And then you've got all of these, everything here are these adjustments that you can make. All right. Now you can actually, you can draw, like, let's say we're going to hatch the parking lot, for instance. And we'll take that pattern, the red color. So it's going to, you can use that to help make a difference. Let's do the pad, and we'll take a solid, if I can find it here, solid. And we'll make that a blue. All right, so you can see, and all this is doing is going to give you a way of making some reports. Now, to show you how you can use those, for instance, I'm going to go back over to here and then show you some items And you have these files, you can, study these on your own when you get to them. But here's some examples. Let's see these reports. Those are the plans. Let's see, there's a, yeah, here we go. So I used this process on this for an actual job. And we actually have computed the raw volumes, see no subgrades, no stripping. There's that 26,300 export. And now here's my materials. I had concrete slab under the building, stone base under the slab, asphalt wearing course, asphalt base course, stone pavement subbase, etc. The adjusted volumes. So the existing surface, of course, it runs off the edge of the page. And then I generated some views of this from existing grade on the ground. And then here is, those are those crosshatch areas. Now this is the main road out here, and it comes up a little grade and comes into this where they built these 3 storage buildings. And then it comes around up to this side here, and they've actually got a little underground vault in that area. Let me see here. There's that to that underground. Here's that little access to climb up to here. Those are the actual building pads. So they're a little bit raised in the front, they're cut back in the back. A couple of ponds they had in there in the roadway that came out. Let's see, what was that? I can't read it. It's some kind of a subsurface vault they wanted to have calculated. So, as this step down through, now here it is with these colored as different regions. So you can see the building pads, the pavement, and then the adjustments. Let's see. Yeah, composite surface, the final merged into the existing with no subgrades. And then there is the subgrades on by color. So nice little series of things you can do with those. Let's look at this one for a minute. I think this is the same type. Raw volumes, materials, material parameters. And I didn't put any costs on these because the company I was doing this for was going to do their bids. So they had their own costs. They just needed the volumes. And this one was a bit more complex because this was the existing ground. There was a parking lot up here. You can see it's drawn there. And it came down and round its way around into this. There was an existing building sitting here that gets torn down. And then here's the area of topsoil stripping. So they're going to strip all the topsoil. This is the disturbed area. They're going to strip all the topsoil, but these areas, because that was under existing pavement and a building, there was no topsoil to have to strip out of those. The topsoil replacement was once it was built, which is now in this new shape, there are areas, little landscaped areas here that they came back and put the topsoil back in at a different depth. And so then that's the materials. Let's see, somewhere there we've got an adjustment on that. Now here's your final surface with no subgrades. This is just what it looks like from the street. The road came in and climbed up around this outside edge. And this building was actually, split. There were two slabs, the 2-story in the front and just 1 story in the back. And it actually has, there's a little loading dock, everything there that we modeled. And there you can see there's the topsoil stripping that was from that original topsoil replacement. That final view. There you can see around the back where, we even modeled the steps coming up to their loading dock area here. And you can see the little landscape boxes where that was cut down and then put back with your topsoil replacement. And then there's your final grades, the little landscape boxes, the street out in the main drive, the pink for the sidewalks, the pavement area here, the building. Again, little retaining wall in here that it comes back in. There's a man door into the building right there, but the road then climbs up and it's got another little loading area back here as it came around. So, and then there it is from the backside. You see it coming up. There's that little loading dock. So all of this was done, and you can see there's your final surface, and that has the subgrades and materials. So you can see how the parking, all of the asphalt and stuff is cut down inside the backs of those curbs. Same thing here with that building slabs, a concrete slab at the top of it. You can see how it's dropped down. All right, so those reports are in each of these different examples, but there's also some things in here that there's like oh, that's the output. Sorry, I need to be in this one. So there's the actual set of drawing plans, which you can see has, these are just PDFs, and that's probably the way that you get most of your information, is I'm going to guess.
We primarily do bridge contracting for DOT.
Oh, okay. So
And they send us microstation DGNs, which are
okay. So you get those.
terrible when they're imported. So hard to work and get them cleaned up.
Yeah, you can actually, Carlson will actually work directly in a DGN file, but you're limited to a lot of things. And it's best usually to just import it and go from there. But you can see this set of drawings, when we brought these in, these were just dead flat PDFs, and we had to elevate the contour lines. And also when we trying to take the building, each one of those little dots is an individual entity. So, we had to get those, and it was on the same layers as the outline of the perimeter. So we couldn't just freeze the layers. We had to, it was a mess. But,
Yep.
you can see now whatever markup was done out here, but they've given us, wall elevations, curb elevations, building footprint elevations around the back, and back here's that little stair step that came up, loading areas, etc. So, all of those are brought in to our into Carlson. We just took them from the PDFs. Now it'd be much nicer if we'd had the original CAD files to start with, but we don't, or we didn't on this job. And this is the drawing that I made from bringing this in. So, we came up with this one. we took that grading plan, C200, which was this one right here. So that's what we took, that brought the PDF in and made that into our grading plan. And this, you can see the underlying existing contours. These are our graded contours. So that actually defined the limits all around those graded contours. That was their perimeter, where it touched down out here to existing ground. So that's why the example that we were looking at here, where it only went out to that little drawn perimeter out here, it didn't accommodate this. And you can see that's significant. That's, 35 up to 50. It's at 40, 50, so that'd be 1160. So starting down here at 1135 to 60, well, that's 25 feet. I mean, that's a significant amount of work. So you need to make sure that you accommodate things like that. But now you may not have, that severe a thing when you're working around a bridge and you're just working to get the abutments going. But I don't know. I don't know what part of the, is it flat, where you are mostly?
No.
No.
We're up in Maine. So
Yeah, I mean, I don't know much about the geography up there. I just, all right. So these are, and these are some additional things. That's the erosion control plan. So all of this kind of stuff, we can bring those sheets in individually using CADNet, and working those as well. Now, there's another folder here called, what not to do. Here's some, let's see, these are PDF source files. But yeah, there's this folder here called what not to do. Let's see, what do we have? The PDFs. All right, so what not to do is an example that we've got in here that is, if we, let me take those hatchings off. Erase subgrade hatches. There we go. All right, so if we open that, let's go up a folder and look at what not to do. And what this is another typical design, but we wound up with, there's a real mess with the stuff going on to begin with too. So we had a lot of this stuff was elevated. But if you were to go and actually look at these contours and how they lay across the site, these are just drawn contours. They're just, somebody drew them on here. They're not actually tied in. You can see this elevation is 56. Well, that one's 47. So 56, this one is 55, 56. So that comes up there. Now you've got all of these little varying floor elevations. Those are fine. But now, where does this go? Where does it tie? They've left a lot of this stuff off. There's places like here, they're showing this line here as a water line, but you can see it's not a water line, it's the curb, right? So, there's a lot of stuff you got to look out for. Here's another curb, and you see the contour. Well, that curb line is probably, and same thing with this contour. So the curb is probably, that's the flat part of the curb. Or, it comes here and then it climbs up to so from right here up to here. So if you were to draw from here to here. Being a contour. I don't see it, but so what they've done with this drawing is they've left off. That's well, that is a 3D polyline, but they've left off the other edge of the curb that probably would be from this point here to here to here to here. Like this. Now, if I were to go and model this as a curb, what I would wind up with would be hold on a second, I got to put my settings back on. Yeah, so what I would what I would see by doing that is that I've got these two lines. If I look at that elevation of that grip, I look down my status bar, that's 842.91, 843, and this one is 843. So that's that point there is the same elevation as this point. And that's just a tenth under it. So, you know, they've got some issues with this drawing. And the only way that, you know, you can find all that stuff out is to actually go through these things and look at them. And either try to interpret it or send it back to whoever gave you the file. And I know that's hard to do when it's the DOT. All right, so there you can see.
Yeah, most designers send out like make you sign waivers and stuff that
Yeah.
this
And you
is
know,
for informational purposes only. And
yeah, you know why that is, don't you? It's not, you know, we get the old official saying, and I'm an engineer, so I've worked for people that do this, is that they say, well, we don't want to give them the whole model because we don't want them to take something and then it comes back on us with liability reasons. Well, no, what you're really saying is that you're not sure of what you did. You're not real confident in what you did, and you got your drawings approved by a clerk somewhere. And so everything else is just going to come down to verifying during construction, right? So you're not going to see um, a lot of these engineers volunteering all this information. But if you can get the engineers to learn how to build these models correctly, then you can really say, see, I can look at this right here. This is as a contour line, right? And you see that little jog right there. So there's a flat spot there. And, you know, somewhere this thing climbs the face of a curb and comes back around. Here's a case where this contour line right there is elevation 56. This is elevation 56. Now, this as a contour line cannot touch this as a contour line. So there's something that needs to have been resolved in there. So somebody's, you know, gone in here and drawn a bunch of contours and turned it in as a job. So that makes it really tough to try to identify, you know, how these things are going to work. So these curbs are and even if I knew a curb width, if it was say 6 inches, I can't just offset this curb 6 inches unless it is a triangular curb. So if this is the top of my curb and I'm coming down 6 inches, but also out 6 inches, well, that's fine. But some curbs are actually, 6 inches flat across the top and they drop 6 inches vertically. Well, so
Right.
how I would do that was to be, back offset to the back by interval method of, 0.5 and 0. Take this guy and bring it there. And I would run it again and I would say, now I can't do it. I have to put a little bit. So I'm going to say a 0.05 and I'm going to put a minus 0.5. All right, so that now would give me my vertical curb face. And then if I had a gutter pan on there, uh, maybe, let's say 1.5 foot, so an 18-inch gutter pan by percent of a 4%. And I would take that outermost one there and bring it that way. All right, so now when I look at that structure in 3D, I can actually see, that's the way that would get built. And that would be the correct way to build that. You've got you can see right there. See, it's got the 6 inches across the top and it's got a vertical drop. Now it's enough kicked out away from it so you don't get those vertical face errors. But so many designers, they're just going to draw you a single line, call that a curb, and they're going to expect you to know how to handle it. And so, just back out of here. And
Draw
I've
lines
seen
right
that.
on top of each other, like that's
Yeah,
edge
and
pavement and face a curb and
yeah, so I've seen them do that. And just like the one that you saw in this other drawing, they had one line drawn, but they had multiple elevations. So they're saying, okay, well that's my curb face, but they don't tell me anything about the back of the curb. They don't, if indeed there is one, and there is, I probably should have offset this one backwards, uh, 1/2 foot. And we'll say 0.5 and then 0. So that's really what those curbs should probably be looking like. Um, and same for here. So you don't get that because it depends on the designers and the styles are different.
yeah.
And they, and they'll draw these two lines, which we had to use to model with, they'll draw as a single line because they're really one vertically on top of the other one. And then they'll just put little labels on them. Well, so those are some of the things you've got to do to try to clean that file up to get it into shape to use it. So now,
And that's a lot more information on that drawing than I ever get
oh, I imagine.
for grading.
Well, if you'd like, what might be a little more useful in your case would be to take one of your drawings. If you've got that, maybe we can work on that tomorrow and step you through your typical workflows and maybe see something that we could do a little differently to help you get that managed. Would you like to do with that? Well,
Um,
do you have
yeah,
any files that you've got, maybe an old file or something that you've got? Now, you may not be able to. I know you might have non-disclosure issues going on, so
no.
I'm not going to do anything with it. But if you've got, you know, the if you have the permission to use it or you want to disguise it somehow, and I'd be glad to do that as part of your class if that would be helpful.
Yeah,
Uh, yeah, and you don't need to. That's fine. Particularly if you've got like a DGN file that, like when you get your DGNs, do you typically do these imports
Yeah.
and try to bring it into a DWG, or if you can actually open a DGN directly,
Right.
and I've not really done a lot of work there other than I know it shuts down a lot of the functionality that you don't have if you're working in a DWG. So that's still your best bet is to do the import. Now, I've got one a little better is I've got MicroStation on my system, so I can load it up in MicroStation and save it as a DWG file, and then there's no conversion needed. And that's really a great conversion that MicroStation does because they're a lot better programmers than the ones Autodesk has. The Bentley programmers. And so I usually do it that way. I go into MicroStation and export it instead of going into AutoCAD and importing the DGN. I'll export a DWG
Ah.
from MicroStation. But that requires you to have MicroStation. If you don't have MicroStation in-house, I wouldn't necessarily suggest you go out and buy that unless you want to. It does save you some time, but
So when you open the DGN in Carlson,
uh-huh.
can you save it as a DWG?
Well, that's a very good question. I think maybe you could. Let's give it a try. I've got a few here. So let's open and let me find a few. Let's see. Go out here to my Windows world and my documents, consulting projects. Let me see what might be a good one. Mount Vernon. Parcels. Try this one. I'll open that up. All right, so now I've got a DGN file open directly, which contains this right here is set up as an external reference, which is, it's on a layer called building. That's pleasant. Let's see what that express actually is. See, I've got a whole different interface up here. Let's see. Let's view layer control XREFs. So I've got these. I've got a boundary annotation and boundary parcels and building lines. Got those two files. Let me see, was that in? And it kept those as DGNs now. Well, boy, that's not a bad, I think Carlson's import's better than Autodesk's. So we've got these townhome layouts. Let's see what it looks like in 3D. And so everything that was elevated were these contour lines. Now the labels, all those are just blocks, like shrubs and trees and such. So yeah, well, that would make a nice little thing. Now it's a single entity. It says it's an external reference and it's unnamed. So that's actually a terrain model that's part of the DGN file. And if I can, I can't bring that in directly. I can bring in, if I'm in DWG mode, I can actually bring in a Civil 3D file that has the surface built into part of the drawing file itself, just like MicroStation does. All right, so now we've got this file. Let's see if we can't save as, or even export. We can export a DWG. But if we do a save as and change, no, we cannot change that way. But if we export it, and see, this is where we might get into trouble. If we export a DWG, it's going to go back to our file area. Carlson projects. Data sets getting started. So we'll call this one check for you. We'll just keep the same name. And let's see, export enter model name to import. Oh. Oh, I see. Oh, that brought in the rest of the file. I see. It was waiting on me down there on the command line. Yeah, see, I can't use that command. I can do a regen, so that'll work. And I've got these layers of 3D edge of pavement, but I've also got an edge of pavement and a back of curb. So they had, this is actually an incorrect. So I'll just get rid of all of those. These are all like drainage areas and wooded areas, that kind of stuff that were done for that file. So now if we export a DWG, we'll go back to where we were. Awesome projects, our class, our getting started, check for unit size, we'll save. So we did it already. Now let's open that as a DWG and see what it lost. It was called check for unit size. There we go. Let's see what it comes up with. To use a geolocation map. All right, so now there it is. Looks nice. And I can verify those are the same colors that were in the DGN file, so it did the color table translation correctly. And let me see if I kept any XREFs. Oh, look at that. It brought across all of the external references and the images. Oh, and not only that, look here, it brought in these drawing files that were layouts. They're actually individual modules or models. I've got some issues here, like my text was, sort of screwed up, but in terms of getting it modeling, oh man, it looks good. And that brings that across as a block. So that whole surface is a block. Now, if I were to explode that block, I could then use those to See, I've got, that's a contour line elevation 1180. Here's the next one up. It should be 1182. There it is. So yeah, that just exploded that into contour lines. I could then isolate those layers and turn that into an existing surface. Although I also have those surfaces available in the DGN file that I could um, I could, if I were in Bentley, I could export that through Land XML. Let me see if yeah, I don't have. It's looking for an external file. That is still, okay, kept those as individual polylines there. Huh, well, I don't know. It looks like they've really improved it. So yeah, you could open the DGN and export the DWG. Yeah, it even brings in the microstation line styles. Look at that. Oh, actually, I'm in the DGN. So now if I go back to here, to my AutoCAD file, where were those? Yeah, see, that's the building lines. That's actually an XREF too. Yeah, and see when I reach in those lines, see how they change? And if I zoom in down here, you see how they change size? That's a microstation line. It's set to do that automatically. Well, I'm kind of impressed. I'm glad you asked that question. Yeah, so it should work. Huh.
Right. Yeah, yeah. Try to do that from now on because I've been, I don't know, it, it's kind of a crapshoot on what the drawing looks like when it gets imported because like they have so many extracts and they send you 30 drawings and
Yeah.
you open up the plan and there's 15 XREFs.
Well, another thing too, yeah, you've got all those reference files, but another thing is that some people use MicroStation in different ways. Like some people will make a separate DGN for everything that they're doing, like a grading plan, um, centerline alignments, there'll be a 2D file and then they'll reference a 3D surface model and all these different kind of things. But MicroStation has the ability to have multiple models within a single DGN. In fact, you could put an entire highway bridge job in as a single DGN file, and just every one of those different considerations lives in its own separate model.
Yeah.
Some people might work that way. Most people don't because they work in what's called a federated environment. They've got multiple designers working on different aspects of the project at the same time. So they
Yeah.
need to sort of separate out those individual parts, which is why that's done that way. But they don't have to be. And a lot of the stuff that I do, because I'm a single person consultant, I like to keep everything in a single file and I just work within the models within that file. So
Yeah.
it just depends on how the people work that did the originating as to what you have to do with it once you get it. And whereas there's no magic done button that I can show you that you press to where all that's done, other than I can tell you though that I'm aware of what you go through. It doesn't help much, but but I know exactly what you're talking about, and I've had to do that kind of stuff plenty of times. So, um, but anyway, that's that. Now, tomorrow, what we will take a look at is when you get a file, uh, do you, do you ever have to assign elevations to anything?
Oh, yeah, almost exclusively, really.
Okay, so that's what I want to show you. Do you use the colors in Takeoff to help guide you to doing that? You notice I turn my colors off and set everything back to color by layer. But what we'll go through is, see if I look back at this drawing here, if I turn that color stuff back on under my Takeoff settings, I'm going to say automatically update, and I'm going to assign them by elevations. And anything that doesn't have an elevation is going to be red, but anything here, if I assign these colors by target, they're going to be existings are green, designs will be, let's make them uh, blue, and other is going to be this sort of gray. All right, so I'll say okay, say exit. And so now I see that, it doesn't do it for everything. Like here's a piece of text that still has a color is by layer because if I put that text layer, and that is called index label. So if I go to this and go to other and find index label and move it to existing, it may or may not. I don't think it'll change it. No, it doesn't. It keeps text as the same color that it started out with. But now I can look at this very quickly and see that, hey, green is existing, blue is design, and this little, say this line here, that little outside stuff is other. When I look at, say, this one, and that's the same way, if I've got my, I'm going to update colors, percent elevation. Oh, you know what? I don't have this. I don't have these defined. There we go. So if I were to go through here then and say, all right, I'm going to identify the layers for existing. So I've got these, this, and this, and oh, I don't know, anything else that might be existing. And then if I repeat that, let me go back to set colors for design. Well, now I've got, say all of these contours, but I've also got, building footprints. There's my Z pad, um, curb lines, things like that. And now let's see green, blue, and no elevation. Say okay. The exit. Now we'll update my colors, set elevations. All right, so all my green are my existing. My blue is my design. Looks like there's some other lines in here too. So set these. Okay, so I set those to be part of the design, but they didn't show up blue because they have no elevation. So that tells me when it's red, I need to elevate those particular things. So here's my contour line, comes up, hits this curb face, and walks it all the way around to where does it come out of it? You know, probably somewhere way over here, somewhere. Um, so that tells me I've got that. Now I've got another little contour line here, P grade 2. I don't know what that would be. But anyway, you can set those up to be based on those colors, and then you can also turn on your, if I just want to, right now I've got all three of them on, so I'm going to turn off my existing elements. And I'm going to go down here and turn off my design elements. And so everything else down here left is other. So it's like, you know, curb lines and drawn water lines, things like that. Now, obviously, these are part of design, like phase 2 and things like that. But you can limit those, and those are just toggles, design and other. And then you can, if you turned on the toolbar, let's see, let's show toolbar, Carlson, take off. Let's see, take off general. Carlson, and take off reports. And take off display. Now, these toolbars are up here now. I'm going to pull these down just to show you. I don't know why it won't squash back down, but anyway. So this is what I generally do when I'm doing a big session with this stuff. I'll have these things lined up, maybe just tuck them up here at the top of the screen. So this is your typical workflow. Here's your checklist, or I'm sorry, that was the import a PDF, do a drawing cleanup, define your layers and materials, set your boundary, then make existing, make design, calculate your total volumes. Remember, we did all that. They got things here. There's your surface inspector. There's your 3D viewer. Now this part in the middle, there's your reports. There's your material quantities, custom reports, et cetera, et cetera. Then over here is that set layers for existing where you picked it from the screen. And then here are your display toggles. That was the existing. Here's the design. So I'll turn the design off, and I'll turn the other off. So now I'm left with only the design elements that I chosen from that list. If I don't want to see them, I turn them off, turn the other on, or just get other out of the way so that I'm looking at now just design. Okay, so, and again, for design, I look at these and I see they're red, so they need to have elevation. So if we gave it elevation, I'm just going to go through here and select those and give them an elevation of, let's just say 100. Now, once that's done, and I've made the change, if I go back and update my colors for elevation, you'll see those are going to change to blue because they now have an elevation. And there's other ways to set elevations. Let's say if we set turn my other back on and read. Those are my design. Let me get that. Turn the back off. All right, so now if I made all of these polylines. At an elevation of 0. Okay, so we brought in a file here, and you're going to see them turn red, okay, because they have not been elevated. But we have some commands in the elevate. If we're going to set our contours, we are going to I'm sorry, assign contour elevations. You can do these a number of ways, from labels or multiple in series. So if I do multiple in series, I know I'm going from 830, 830, 31, 32, all the way up to say 842. I'm missing, say 40. Oh, I have no idea. They're too far apart in there. Anyway, let's say we went every 1 foot and every 5 feet, and we're not going to change the properties. We're just going to give it the elevation. So I'm going to set here, I'm going to say maybe start here and go up to here. And we're going to start with 830, up or down, what's going up. And so now it goes through and it sets those at their elevations. See, there's 840. And as soon as it sets the elevation, it changes the color. Okay, and it now is a design element, so it's blue and it has elevation. So that's how those colors can help you. Don't have to then constantly go back and check. Let's say, okay, I've got to elevate those, or even, if you're doing your 3D view and you view your stuff and you see, oh, I've got something in there that's not right. It's, oh, there it down is there. So I've got to figure out what's at elevation. So if you don't, you're constantly needing to look this in 3D to make sure you've elevated stuff, unless you use this color feature that only Takeoff and the construction module, which is your version of using Takeoff, it only has that. Civil has a SiteNet menu that works similar to it. You see this display existing, design and other, make existing, make design. There's your set the layers. The same way as we had, see, there they are. Well, I'm in a different file now, but so that Civil has that, but Civil can't do the update colors. So Civil won't do all that automatic color changing for the elevation, but construction will, and Takeoff. And it's a really useful tool. And if you want to put things back to the way they're almost always drawn by layer. So you could, just instead of now using those, if you go back then and turn your, turn your Carlson configure Takeoff, and if you say you don't want to use these green for existing, blue for design, gray for other, and you could just turn those things back off, and then you could select everything in your drawing and go to its color and the properties and make it back by layer. And so it'll put it back to the way you probably started with this thing to begin with. And then of course you could turn on your existing, turn on your other. Oh, I'm sorry. Turn on the existing. There we go. Turn on the other. And now we would be able to do it with all these colors. Well, object limit exceeded. Okay. CH prop, all. Color by layer. There we go. So now that's back to the way that came in here with the layers having the various different colors. Okay, but using that layer or using that color feature to be able to define your various pieces, whether it's design, whether it's existing, whether it's other, and whether or not it has elevation or not. Okay, so it's a really nice and handy feature. And it's something that, again, you only have with construction or with the takeoff standalone, but it's really, really helpful, I think. Okay. All right, so we're about 8 or 9 minutes past the pumpkin time, so I'm going to let you go.
All right.
And when we come back tomorrow, we'll take a PDF and bring it in and learn all these various tools to get everything elevated so we can get that stuff, brought up to what our design would be. Okay.
All right.
Or anything else that you may think of that you might have some questions with, we can ask those tomorrow when we get going.
All right.
All right. Okay. So I will stop our recording.